Good morning, sir.
Yes, good morning. Good morning.
Sir, with your permission, can we start our session?
Yes, sure.
Yes, sir. Good morning, sir, and good morning to all the participants of the FDP. Sir, I welcome you to the FDP program on recent trends of control system and power electronic converters. It gives me immense pleasure to introduce about Dr. Atma Ram Gupta, sir. Sir is currently working as an assistant professor in Department of Electrical Engineering, NIT Kurukshetra. He received his BTech in Electrical Engineering from Biju Patnaik University of Technology, Rourkela, MTech from NIT Durgapur, and PhD from NIT Kurukshetra. He has more than 30 papers in various journals and conferences. He has written around 7 chapters for various books in Springer. He is a member of several professional bodies like senior member of IEEE and IEEE Power and Energy Society, member of IEEE Young Professionals, and many more to list out. He is a reviewer of several national and international journals. His research interests include power systems, renewable energy source allocation with defects in distribution system, distribution generation, application of power electron.
Yes, am I audible?
Yes, sir.
Okay, so thank you, Dr. Anil, for a nice introduction. So, may I start now?
Yes, sir. Yes, sir.
PPT is visible to everyone?
Yes, sir. Yes, sir.
Okay. Okay, so we will see today that some some applications of power electronics in power system. So, what is the application of defects devices in power distribution system? Am I audible perfectly, na, Anil ji?
Yes, yes, sir. Yes, sir.
Yes, sir. Okay, okay. So we will see applications of defect devices in electrical power distribution system along with DG. So nowadays we all know that the entire world is moving towards EV. And other renewable energy sources is also continuously growing. So along with that, there is a need of reactive power requirement to maintain the voltage profile of the network and to resolve the other power quality issues. We need to give proper reactive support into the system. So today we will discuss this how optimally we are allocating defects devices. So here I am using defect devices for distribution system. Many researchers have worked in the area of transmission system, power transmission system, uh, and they have applied fact devices. But very few researchers have worked in allocation area of the in the distribution system, especially defect devices allocation. We will discuss DG and defects allocation in electric power distribution system. So the content of today's work, this work I am presenting, will be first we will discuss what is the motivation of this work and what is distributed generation, what is fact devices, defect devices, who is responsible for seeing this matter into the system means some network operator is there, a distribution network operator. In another word, in some country we can see say ISO. Okay, so here DNO is there. Proper load modeling. What are the defect devices we can use? DG and DStatCom allocation in distribution network. Then we will see what will be the impact of reconfiguration of distribution network. We will discuss some results and major references. So coming towards the motivation of this work, renewable energy sources integration is the first motivation, and renewable energy sources integration has shifted the paradigm of power sector operation. So previously, there is one way of that power transfer. And now, consumer, whatever consumer is there, we can say it is not only the ideal consumer. Nowadays, consumer have also right to produce power. Okay, that is called prosumer. Okay, so producer plus consumer. So one word that is called prosumer will be there. So consumer have the facility now, and they can they produce power from their own installation of renewable energy sources like PV panels. Okay, so there is a concept of microgrid. Okay, so microgrid is can be grid connected or in isolated mode. So with all these things, we can see that paradigm of power sector operation has been shifted from passive to active network. So next, distribution system operation is changed bidirectional power flow due to bidirectional power flow as we have discussed. So with the growth and development of power grid, utilization of existing electrical network is very important. Okay, so the things are changing means the demand of power is increasing, and that our fossil fuels are less, as we all know. And we reached, if we see, if we will see, our total installed capacity is reached around 390 gigawatt. Okay, so and the renewable percentage, if you will see, for India, it is around 26% now. Okay, so more than one fourth of the power is produced from the renewable energy sources. Okay, so with the growth and development of power grids, optimal utilization of existing electric network is very important. Okay, so because of high cost of construction and development of power networks, mitigation of existing issues such as excessive power losses, voltage profile problems, voltage instabilities, and power quality and reliability problems, etc. is inevitable. So we will discuss some power quality issues, uh, harmonic load flow, etc. So I am experiencing some
Yes, sir.
background
Uh,
now noise.
yes, sir.
So
Participants, can you please mute your mic?
or you can mute by yourself
Yes,
all.
sir. Yes, sir. Yes, sir. Yes, sir.
Okay,
Hello?
so
Yes, sir. Yes, sir. You can continue.
okay, thank you.
Now it's
So to relieve these problems means from these problems of power qualities. So to avoid these problems, DStatCom can be used as a shunt compensator devices in distribution network. And who will take care of installation of DStatCom into the distribution system? Where to install? What will be the size of the DStatCom? And if we are installing the DStatCom, it is very costly. So how to recover the cost of the DStatCom from the consumer. So these all things will be taken care by the network operator. So distribution network operator will take care of all these things. So DNO, in short, being a key element for energy distribution and has the major responsibility for secure, reliable, economic, and efficient operation of distribution system. So accordingly, where to allocate D-STATCOM to solve the power quality problems, DNO has to plan accordingly for the secure, reliable, as well as economic network with renewable energy sources for making an efficient system. So planning of distribution network with renewable energy sources has changed the facets of the network operation. Hence, distribution network study with optimal placement of DG. DG can be renewable energy sources or non-renewable energy based DG, and along with the defect devices is of utmost important. The work has addressed the important issue of DG allocation in the competitive structure along with the role of defects. So, so these are the things we will discuss in this today's presentation. So, just for sake of starting, we all know what is the power system: generation, transmission, and distribution. So, distribution system are undergoing rapid changes in the recent decades due to increasing implementation of renewable energy sources based distributed generation. So basically, this work is concentrated on the distribution area. Since distribution area have more problems, so distribution system problems are high R by X ratio, which results in high power loss, which leads to voltage instability, and has maximum power loss and has the lowest reliability. So these problems are there from the long time and handled by basically conventional series voltage regulators and shunt capacitors. Means regularization of voltage in case of light load, voltage profile can be enhanced, and in case of heavy load, voltage profile will be poor. So this will indirectly impact the power quality and THD of the network. Okay, so conventionally we are using shunt capacitors or voltage regulators. So uh, to handle these problems. So, but the problem with these devices, shunt capacitors are generally used for heavy load conditions to maintain the reactive power, uh, but shunt capacitor cannot able to generate continuously variable reactive power, and our load is variable. So the option for solving this issues, we have to make it variable. Okay, so variable capacitor, we can say this is the uh, we can say it in another form. This is the fact devices where we can vary the capacitances, we can vary the reactances. Okay, so conventional series voltage regulator and shunt capacitors are used. So conventional series voltage regulator cannot generate reactive power and have quite a slow response because of their step-by-step operations, and so these are the problems which can be solved by the fact devices, and it is used in the distribution area. So that's why it is called defect devices. Okay, so here we have used D-STATCOM, distribution static synchronous compensator, which is shunt connected voltage source converter, and the result is low harmonic distortion, and it is a small size, low losses, automatic operation, no resonance problem will be there, and can operate continuously. So it improves voltage regulation, voltage balancing, and reduces power loss, and solve the power quality issues and reduce the TSD of the network also. So now we will see what is the difference between central versus DG, distributed generation. So central generation, we all know that thermal power plant, nuclear power plant, and bigger hydro power plant, we can take it as a central uh, power generation. And distributed generation and or dispersed generation, we can say distributed generation is there, solar based generation, wind based generation, fuel based, and micro turbine generator. So these are the small generations which is distributed in nature. So again, if you are categorizing distributed generation, there are two kinds of distributed generation. That is, one can be renewable based distributed generation and non-renewable based distributed generation. Of course, we are motivating with the use of renewable energy sources, because non-renewable energy based increasing the greenhouse effect, as well as non-environment friendly, and also it is very costly. Okay, so diesel, natural gas, or kerosene based, even if nowadays if you will see for the irrigation purpose in many states, we are using solar based irrigation system, uh, and motivating farmers to use solar based that irrigation in the irrigation system. Solar based pump is there for using in the irrigation purpose. So it will reduce the that their cost, and also it is environment friendly, and government is also giving so much subsidy on that. And also it is their own micro isolated microgrid type of system, and it will reduce the burden on the power transmission network. So so many advantages are there with the renewable energy based DG. There is technical as well as economic as well as environmental, so benefit is there. So wind-based energy is the highest contributor among renewable energy sources in India, and second is the solar based renewable energy. So these are the technology option for distributed generation. Next, if we will categorize as per the power production of the DG. So one DG is the type 1 DG, which can inject real power only into the system, like photovoltaic based DG and fuel cell based DG. Type 2 DG is capable of injecting reactive power only to improve the voltage profile, like we have discussed capacitors or capacitor bank, we can say synchronous compensator, KVR compensator, etc. So next is type 3 DG. Type 3 DG is capable of injecting both real and reactive power into the system. The example is a synchronous machine. So both under excited and over excited mode can be used to increase the to give the reactive power or to take the reactive power. So both mode can be used. uh, so in overexcited mode, it will give the reactive power, inject the reactive power into the system. Okay, so next is type 4 DG. DG capable of injecting real but consuming reactive power. So induction generator used in the wind farm is the example of type 4 DG. So these are the types of DG used into the system. Next, if you will see the what can be the size, so various that agency have given various the definition. So IEA defines DG as a source of generating electrical energy on site at the consumer end to provide the support for the distribution system connected to the grid. And SIGRE defines DG as the generating source connected to the distribution system, which is not planned or dispatched centrally and have the ratings below 50 to 100 megawatt of generation. So next, EPRI, Electrical Power Research Institute, defines a DG as the generation from few kilowatt to 50 megawatt. So they have again divided like micro DG, small DG, medium DG and large DG. So micro DG is from 1 kilowatt to up to 5 kilowatt, and a small DG from 5 kilowatt to 5 megawatt, and more than that up to 50 megawatt is medium DG, and maximum up to 300 megawatt can be under the category of large DG. So if we will install these kind of DG into the network, in the distribution network, what are the technical and economical benefits? We can discuss it here. So first benefit will be their voltage profile improvement. Okay. So next is that if we which in turn it will reduce the losses, because once we are increasing the or maintaining the voltage profile up to 1 per unit into the system, so where losses are that voltages are poor, and if we are maintaining the voltage profile, so obviously that current will come down, and line losses I square R, or we can say in the three phase 3 I square R losses will be reduced. So with this reduction of losses, the total demand will also get reduced. Okay, so the demand from the grid, overall the demand from the grid will be reduced. So next, transmission and distribution cost can be reduced since the DG units are closer to the customers. Okay, so unnecessary transmission can be avoided, transmission of the power. So DG can be deployed at the consumer end only to reduce the cost of transmission, and overall benefits can be given to the consumer only. So next, spinning reserve support during the generation outage. So DG can be treated as a spinning reserve also when there is some generation outage. So next, environmental impact in terms of reduction in polluting emissions as compared traditional power plants. So we all know that traditional power plant, mainly thermal power plant, is a bigger source of SOx, NOx. So SO2, CO2, and nitrous oxide contents are increasing from the thermal power plant. And if we are using renewable energy based sources, these contents of CO2, SO2, and other sulfur oxides and nitrous oxides will be reduced, which will be required to save the environment. Next, implementation of DG has resulted in renewable energy to be widely utilized and realized as a promising source of energy. So DG is available in small modular units, and therefore easier for procurement and installation. So DG provides a flexible way to choose a wide range of combinations. So these are the some features of DG we have discussed. What will be the technical benefits? As we have seen, some DG will require reactive power, and reactive power support into the transmission network can be given from the FACT devices also. So first we will see what are the FACT devices. So some definitions are already you know that FACTs incorporates power electronics and other static controllers to enhance controllability and increase power transfer capability. Okay, so and it provides control of one or more AC transmission system parameters. So we know power transfer capability P, we can defining sending in voltage into receiving in voltage upon total reactance into sine delta. So ACT devices provide control of either reactance or delta, or that sending in voltage or receiving in voltage. So provides control of one or more AC transmission system parameter. So it provides flexibility and ability to accommodate changes in the system or operating condition without violating stability margins. So what are the fact devices we can use, and what are the available fact devices? So the classification of fact devices based on connection used are it can be shunt connected controller, or series connected controller, or both combined series controller and combined shunt controller can be there. So next, if we will classify based on power electronic devices used in control. So fact devices can be variable impedance type and variable source converter based. So variable impedance based, if you will see, that is SVC, TCSC, TCPST, and variable source converter based is that STATCOM and SSC, IPFC and UPFC. So these are the fact devices we are mainly using into the transmission network, uh, uh, because it have so many features which will support to enhance the that effective power transfer. So power flow is not directly controllable to change the way power flows in the system. So we need to change line impedance, voltage magnitude, or angle differences. So by doing any one of these, we can control the power flow into the system. The benefits will be there: reduce transmission losses, maintain acceptable voltage, relieve overload lines, improve stability, and full utilization of the existing system. What are the limitation of this fact devices is the cost, because it is all costly devices, and what can be the optimal size, where to install it, how to maintain, and testing is also based on RTDS system. So these are the some limitations. So similar to the fact devices used into the transmission, we can use defect devices into the distribution system. And here mainly we are using these three: D-STATCOM, DVR, and UPQC. So D-STATCOM is shunt connected devices, and DVR is series connected devices, and UPQC is both shunt and series, the combination of D-STATCOM and DVR. So at the same way, UPFC, UPFC, we are using STATCOM and SSC. So the STATCOM, the D-STATCOM is a shunt connected voltage source converter based BSC utilized to increase the efficiency of distribution system by providing reactive power support to improve the voltage profile and to reduce the line losses. So what are the usage of D-STATCOM? That is the flicker. It is used for flicker compensation, reactive power compensation, and also it can be used as harmonic filter. Next is that DVR. DVR is a series connected voltage source inverter utilized to inject appropriate voltage components along the distribution feeder to balance the line currents. Also, it is the particular application is that sag swell compensations. Next, UPQC, which is in UPQC, we are using both STATCOM, D-STATCOM, and DVR. So UPQC provides simultaneous shunt and series compensation with a series and a shunt inverter. The shunt inverter injects a shunt compensating current to the load in order to provide load reactive compensation and to compensate the harmonic distortion created by the load. The series inverter is used to mitigate voltage related problems, for example, sag and swell in supply voltage. etc. Basically, it injects a series voltage to the load. So usage is under voltage or over voltage compensation. So here in this work, we will basically use D-STATCOM for reactive power compensation. So what is basically D-STATCOM? It is connected at the point of common coupling in the distribution network shown in the figure. The main function of D-STATCOM is to fulfill the reactive power requirement as per demand of voltage regulation. The main components of D-STATCOM comprise of VSC, voltage source converter, transformer, and DC bus capacitor. So the VSC is used to convert the DC voltage into AC voltage with the synchronization through capacitor. The transformer used is to match the converted voltage with the line voltage and compensate the neutral current. Next, we have seen briefly what is DG, what is defect devices used. Next, we will see the roles and responsibilities of DNO operated competitive distribution power market. So as we have discussed earlier also, who will take care where to install these devices, what should be the rating, and if we have installed, how to purchase, how to procure, and how to remunerate remunerate the company or that producer who is giving that costly devices. So the responsibility of DNO has been categorized in the 4 blocks as shown in the figure. So the first is that remunerate all reactive power sources. Whatever reactive power sources is there into the system, DNO have to take care of remuneration of all the reactive power sources. Also, fair pricing mechanism. Okay, so fair pricing mechanism should be there, and for the consumer as well as prosumer. Okay, next, put a stop of market power. So here one term is there, market power. Market power is meaning what? Say for example, if you have to buy something and there is only one shop for that in your area. So whatever they will keep the cost of that particular thing, you have to pay for that. Okay. So, but if so many shops are there, there will be competition, and uh, they are not unnecessary that give burden to the consumer. So DNO have to put a stop to market power and it capability to function with real power market. So these are the role and responsibility of DNO. Next responsibility is their voltage profile management with optimal deployment of reactive power sources as an ancillary service. Next, distribution network capability enhancement of security, reliability, and economic efficiency. Continuous monitoring of the network, monitoring, control, and dispatching of the energy, transparent and fair pricing mechanism for energy sale. Okay, so till now we have discussed about DG, fact devices, DNO. So these are the all components, and next component is that load. Okay, so we will discuss about which kind of loads are there, how to model the load, uh, how we can able to know the probable load. So accordingly, planning can be done to meet that load requirement. Okay, so here in the power system, the types of bus and load are there. So there are three kind of buses. So one is generation bus, another is load bus, and last one is that slack bus, or we can say reference bus. So generation bus, the known quantity is active power and voltage magnitude, and unknown quantity, there are four quantity: P, active power, reactive power, voltage, and load angle. Okay, so in the generation bus, known thing are active power and voltage magnitude, and unknown thing is that reactive power and delta. And in the load bus, we have how much load, active power load and reactive power load, means P and Q will be known, and V and delta will be unknown. And similarly, in the slack bus, V and delta will be known, and unknown is the P and Q. So these are the types of buses. Next, if we will categorize the types of load, so electrical load, based on nature of the load, we can say the nature is like resistive in nature, or inductive, or capacitive. So nature of load are resistive, inductive, or capacitive. And if we will see the area where we are using the load, so it can be domestic load, commercial load, industrial load, and agriculture load. Okay, so broad category of the loads are this, which we are using into the system. So next, for that modeling of this load, for power flow analysis, we have to model the load, as well as system, that what are the buses, that resistance and reactance value, load at each bus, and these data we should have. And after that, we have to model the load on each bus in terms of active and reactive power. So the active and reactive power of the static load models can be expressed in exponential form as P equal to P naught V by V naught upon NP, and Q equal to Q naught V by V naught upon NQ. So where P naught and Q naught are the active and reactive powers at the bus nominal voltage V naught, and V stands for the bus load voltage, and where NP and NQ are the load components. So here, these two value NP and NQ, if we are putting it as a 0, so at that time what will be there? P equal to P naught and Q equal to Q naught. So it will be constant power load. Okay, so next, if these are 1, at that time it is constant current load, and if it will be 2, it will be constant impedance load. So accordingly we can model constant power, constant current, and constant impedance load for analysis purpose only. And generally, if we are seeing the entire system, there will be some load which will take only constant power, and some loads are constant current, constant impedance, or we can say mixed type of load will be there. So we need to give the percentage of the load as per the available data. So we can mix like Jeep load model. So we have taken 2 for constant impedance, 1 for constant current, and 0 for constant power. So first term is for constant impedance Z, and the second term is for constant current, that is I, and last one is that for constant power. So that is the Jeep load model. So this kind of Jeep load model we can model for both active power as well as reactive power, where the sum of the Jeep load coefficient for both P and Q loads is equal to 1, which is shown below in the two equations. So next, for the planning of maybe, if we are looking for next 5-year plan, so we can have the data of last 5 to 10 years, and accordingly we can predict the percentage growth of into the system, percentage load growth. So accordingly, say for example, if 7% growth is there, so we can accordingly grow the load. So load I equal to load 1 plus R to the power M. Accordingly we can model the load growth. So R will be the rate of that increase enhancement in the load, how much is there. So like 7% if it is there, so R equal to 0.07 I have considered for this work, and M equal to 5 means this is the planning period, so 5 year plan. So R is the annual growth rate, it will be as per the data, and M is the plan period up to which feeder can take the load for any particular bus system. So next is customer load demand in electrical distribution system is subject to change because human activities follow daily, weekly, and monthly cycles. Estimating the distribution system load expected at some time is an important task in order to meet exactly any network load. So we all know that human activities like they are following daily, weekly, or monthly cycles. So accordingly, many industries are also working. If we will see the load profile or load duration curve, we can able to know the load variation throughout the day, throughout the week. From the data, we can plot the load duration curve. Next, we have to forecast the load demand. So how to forecast the load? This forecasting can be broadly divided into three categories. There will be hour to be week, whether we are forecasting for 24 hour or a week. So up to a week, it comes under the category of short-term forecast. And if we are planning for a year, means how to meet the increased load demand up to 1 year, this kind of forecast is coming into the medium forecast. And long term forecast like 5 year plan or 7 year plan, like that, so this is coming under the category of long term forecast. So there are so many probabilistic analysis is there to forecast the load as well as generation of the power. If we are applying the probabilistic technique to forecast the load, so it is termed as probabilistic load modeling. Okay, so in probabilistic voltage dependent load model, load is not fixed. Load is allowed to fluctuate at any instant of time, and possible load demand is generated using Monte Carlo simulation. So we will discuss briefly what is Monte Carlo simulation to model the probabilistic load. Here, load varies continuously with a high degree of uncertainty and depends on customer behavior and temporal factors such as season of the year, day of the week, and time of the day. So in probability theory, load uncertainty can be adjusted by a probabilistic density function, which fit its behavior, like several random variables used to model electrical loads behavior are like normal PDF, log normal PDF. For the very longer duration data, we are using log normal PDF, uniform PDF, and variable PDF, generally used for predicting the wind power production. So next, probabilistic load modeling, we are doing using Monte Carlo simulation. So Monte Carlo simulation is used to pick random values of input variable from their distribution function, and for solving a deterministic radial load flow with these values. The probabilistic solution is reconstructed from deterministic data obtained for each simulation after a certain number of simulations. The number of simulations needed to achieve a precise result with the Monte Carlo simulation is independent of system size and estimated as sufficient for this type of problems is 10,000 to 15,000. So here what basically we are doing, say for example, you have one bus where load is 1 kilowatt. Okay, so we need to generate 10,000 or 15,000 data with the that variance and me that how much fluctuation we can give, say for example 5 to 10%. So random value around 1 kilowatt up to the fluctuated value as per the past record. We are allowed to fluctuate that 1 kilowatt up to that limit, and we are randomly generating 10,000 values. And after that, say for example 1 kilowatt, 1.001, 1.002, 1.005, like that. Okay, so we are generating random values. So, and after that we are calculating the mean and standard deviation, uh, standard deviation of that value. And after calculating the mean and standard deviation, it is used for calculating the probable active and reactive power load demand at each bus. Okay, so these by using a normal PDF function, probability distribution function, we can find out probable active power load demand using equation number 2.3 and reactive power load demand using equation number 2.4. So this probable load will be put in place of a static load in the load flow equations, so we can have the analysis with the probable load. Next, after studying all these components, that what are the important issues of distribution system with renewable energy based DG is the finding optimal allocation. Allocation means finding optimal place where to keep this DG, where to site this DG, and what will be the rating which is most favorable rating for the system. And impact of load modeling, enhancement of reactive loading capability, and cost benefit analysis. So these are the important issues we will see here. And harmonic distortions, how to calculate harmonic distortions based on the voltage profile of the network. So harmonics are the integer multiples of fundamental frequency associated with the sinusoidal components present in the power system, which results to the distortion in voltage and current waveform. It led to the increase in the system losses up to 20%, out of which 27% may be credited to harmonics. In distribution network, the additional power losses are in the range of 4 to 8.5% for various level of harmonics. A smart grid may incur 4.7 to 42.2% of capacity losses if it have 1 to 8% of THD. So some of the power quality issues experienced due to the harmonics are deviation in frequency, voltage or current distortions, malfunctioning of equipments, transients, voltage sags, flickers. IEEE power quality standard 1159 and 1995 defines the various types of power quality problems. The researcher can refer for more details these standard. So next, total harmonic distortion, TSD. What is TSD? It is the measurement of the nominal value of distortion in the waveform of voltage or current due to harmonics. It defines the amount of harmonics in RMS relative to the fundamental component, and it can be in terms of voltage or current. It is represented in percentage and defined by the following equations. Means TSD equal to root under sum of squares of amplitude of all harmonics upon squares of amplitude of fundamental component into 100%. So this can be calculated after DG allocation or defect allocation. What will be the reduction in TSD value? That is also one analysis into the electrical power distribution system. So here this table shows the TSD limit as per the IEEE standard 519. So if voltage is less than or equal to 1 kV, individual harmonics limit is 5% and TSD limit is 8%. And if it is 1 kV to 69 kV, individual harmonic percentage is 3% and TSD limit is 5%. And more than 69 kV up to 161 kV, individual harmonic is 1.5 and TSD is 2.5 kV. As we are increasing the voltage level, we can see this percentage should be reduced. So 161 kV to less than the defined voltage, it is 1 kV and 1.5 to 2 TSD percent. So how to do the harmonic load flow analysis? So first we will see the basic load flow, then we will see the harmonic load flow. So basic load flow into the distribution system. Say for example, we have considered this simple 6-bus distribution system, but a longer distribution system can be very high number of buses, but for understanding purpose we have considered this small distribution system where bus 1 is the substation, and after that there are 5 buses: bus 2, bus 3, bus 4, bus 5 and bus 6, and each have their own load, and load is given like IL2, IL3. The subscript is as per the buses. So load 4, load 5, load 6 is given in all the buses, and branch current is given like branch 1 current IB1, branch 2 current IB2. So there are 5 number of branches and 6 buses are there. Okay, so branches will be always less than the number of buses. If 6 buses there, 5 branches will be there. So here for the load flow method used in this work is that calculation of load current for all the buses. First we have to calculate the that load current, how much load current is there. Then we have to form the BIBC matrix. The formation of BIBC matrix, how to format, I will discuss it later, and or you can follow the paper, IEEE paper of JH Tang, and forward sweep across the line for calculation of the voltage. So here IL5 first we are calculating, then bus voltage 4 we can able to calculate that this is the sending end bus and receiving end is the bus 5. So V4 equal to V5 plus IBR into that impedance of this branch. So accordingly we are calculating from the backward sweep, and we can use forward sweep also. So these are the flow chart what we need to flow follow for this load flow analysis. We need line and load data, means what will be the Rx value of each branch, we need to know, and initialize the bus voltage at 1 per unit, then set iteration count up to I equal to 0, calculate load current, form BIBC matrix, and then calculate the branch current. Okay, then calculate bus voltage and calculate the changes in the bus voltage. So till the time this voltage is less than dV max, is less than the tolerance, we are keep updating the voltage. So after that, if it is less than tolerance limit, then solution will be be converged, and that current will be taken as the final current, and after that we are calculating the line losses, and voltage profile can be recorded. So next, what are the changes in the harmonic load flow analysis? There are several methods which are introduced to determine the harmonic caused by nonlinear loads. They are mainly classified in two categories: transient state analysis and steady state analysis. Transient state analysis are generally time domain analysis or wavelet based analysis, and the steady state analysis are frequency domain analysis based on load flow analysis. Okay, so these are the basics. Next, conventional method used for harmonic flow analysis are based on Newton-Raphson method, which requires admittance matrix and impedance matrix to determine the penetration of harmonics into the system. And due to expansion and development in the power system, the characteristics of distribution system are changed, such as widespread increment in network branches, weakly meshed network, and enhancement of automation technique, which has led to increase in memory requirement along with computation time of harmonics determination by conventional method. So injection of harmonic current source into linear network with a specified magnitude is used in this method to evaluate the distortion in the voltage level. So the steps followed in the harmonic load flow algorithm is just input the system data, that is line and load data, as for the basic load flow, input the harmonic source data. uh, so of course with this harmonic that current is going to change, and accordingly the voltage profile will be changed. So input the harmonic source data, define the base value, and compute the provided parameters in their respective per unit quantities. Run the load flow program and compute the various parameters. Determine the load impedances, final load impedances with the nonlinear load, and compute the coefficient vector of harmonic current. Determine the relationship matrix between bus voltage and harmonic current, and next determine the harmonic load impedance matrix and evaluate the harmonic load flow matrix. So compute the branch current and bus voltage finally, and repeat from step 6. You need to stop criteria is reached for each order of the harmonics. So once we are getting final voltage profile, we can put into the TSD equation, and we can have the TSD percentage. So problem formulation of this work is the aim of this work is to reduce the total power loss along with the TSD, and also to improve the voltage profile in the distribution system. So objective function is defined accordingly, means two objectives there: power loss reduction and TSD reduction. So we have defined it like F minimum equal to P loss plus TSDV, where F is the fitness function, is the total real power loss, and TSD is the average total harmonic distortion at all the buses of the system. So total real power loss is the summation of all the losses in each bus. Average TSD is defined as TSD varied from I equal to 1 to M, where N is the number of lines and M is the number of buses. So TSD limit, the TSD should be less than or equal to standard limit, that is 5%. So after calculation of the TSD, then what we are doing, we are allocating DG and D statcom into the system, then again calculating the TSD and comparing the result. Okay, so optimal location of DG and D statcom, uh, uh, the best possible location of DG and D statcom can be used here. I have used sensitivity analysis. There are other analysis technique is also there to find optimal allocation of these devices. I will discuss it later. So here sensitivity analysis is used. The buses are ranked as per their sensitivity index. The bus which is more vulnerable is considered as finest location. Vulnerable means as with the voltage profile, if voltage is very less beyond the acceptable limit, very less, at that point we are putting the devices. So for DG, the most favorable position of DG is determined by finding the closeness of the bus, which is most vulnerable for the voltage collapse. In this work, the optimal location of DG is determined using stability index proposed by some researcher based on the quadratic equation given below. Okay, so the stability index with this equations, we are putting all the value of Vs, sending in voltage, receiving in voltage, active power, reactive power, and reactance value and impedance value, and we are plotting it, and we are seeing where it is the bus having the smallest amount of SI is considered as the most vulnerable bus for the voltage collapse. Thus, the bus showing lowest stability index is considered as the optimal location for DG. So after first DG placement, the size is determined again, and a bus showing minimum stability index is considered as the optimal location for second DG placement. So in this way, multiple DG can be also placed, and for the STATCOM, the most advantageous location of the STATCOM is established with the VSI, means from the voltage sensitivity index. So it is proposed by one author. The VSI is equal to 4 Rm Pn square upon Qn square upon Vm square into Pn. So this VSI we are plotting for all the buses. Say for example, if 6 buses is there, we are calculating for all the 6 buses except the first bus, that is the substation bus. The node showing the highest value of VSI is considered as contested bus for voltage collapse. Thus, the bus showing the maximum value of PSI is considered as the most favorable location of DStatCom. So after finding the best location to allocate DG and DStatCom to maintain the voltage profile for reducing the THD, uh, so we need to find the optimal size of both. So here just variation technique is used at the first time. So variational technique means we are increasing the size of DG, and we are seeing that from the figure. If you will see first figure number 4 is showing the SI for first DG placement. So SI for first DG placement is shown in figure 4. From the figure it can be seen that branch 26, this is the branch versus SI. So branch 26, that is the 27th bus actually, is showing the minimum SI. Okay, so it is taken as the optimal location of for first DG, and the size of DG, we are putting the DG at 27th bus, that is 26 number of branch. So at the 27th bus we are putting the DG, and then we are increasing the size as per given figure number 5. Say for example 0 means this graph is active power loss versus DG size. 0 means no DG is there. At that time we can able to see the losses is above 200, means around 220 kilowatt. As we are increasing the DG size, say for example for 500 kilowatt of DG, some losses are there. We are recording DG size versus losses. So it has been seen that after some point, if we are increasing the DG size, instead of decreasing the losses further, it is increasing. So from the variational technique, this point can be taken as the most favorable DG size for active power reduction of the active power losses. Once active power losses will be reduced, means voltage profile will be get enhanced. So this size will be taken as the most favorable DG size. Similarly, for second DG placement, after placing this DG, we are again computing SI, and we are following the same technique for second DG placement. So similarly for D statcom, we are plotting BSI, which I have shown earlier. So BSI is plotted and shown in figure number 8. So for D statcom placement, BSI is shown in figure 8. The optimal location for D statcom determined is 23rd branch, that is the 24th bus, where it is a maximum. So the rating of this STATCOM is determined as 1400 kVR. The losses versus this STATCOM rating curve is shown in figure 9. Okay, so as the same way, we are varying the D STATCOM size, and we are recording the active power loss, where this is minimum that is taken as most favorable size of D STATCOM. So it has been observed that voltage profile is improved after placement of DG and D STATCOM, which is shown in figure number 10. So this is plotted for IEEE 3334 bus system, and it has been seen that the bottom line is the without any DG and D STATCOM, and after that we are putting one DG, then we are plotting the voltage profile, then with the second DG we are plotting it, then with the DG and D STATCOM we are plotting it. Okay, so after this we are calculating the harmonic source spectrum. So here I will take 1 and 2 minute break, and after that again I will continue. हाँ सर, वो इलेक्ट्रिकल व्हीकल पर आ रहा है इस बार, इलेक्ट्रिकल व्हीकल सर। हाँ हाँ सर। पिछली बार मेरे ख्याल से के शर्मा सर पर आए थे। ये उनका कुछ आया था कंप्लेन वगैरह। हाँ, इसलिए उसको दिया गया सर। हाँ, इस बार के शर्मा सर का एमटेक हटा दिया गया है, 2 बीटेक का सब्जेक्ट दिया गया है। अब सर क्या कर सकते हैं, तो बस उनका ऊपर से कंप्लेन आया था जितना मुझे याद है। ऐसे तो सर ने बोला नहीं था किसी को कहने। मगर ऐसा था सर। हाँ, आपको तो पता ही होगा सर, आप तो छोड़ी थे पहले, तो इसलिए सर वो एमटेक वाला ज़्यादा ये कर देता है। हम्म। हम्म। कौन बोल रहे थे सर आपको? हाँ हाँ, क्या बोल रहे थे? अच्छा। अभी मैं सर फाइनल, फिर अभी 11:30 11:45 में सर के साथ मीटिंग रखे हैं इसी बात का। तो मैं सर 1 घंटे तक फिर से आपको कॉल करके कंफर्म करूंगा सर। हाँ, पीएलसीएमसी है, हाँ सर। हाँ हाँ। हम्म। 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 हाँ सर। पावरट्रॉनिक्स 2 भी है आपका, बीटेक का। अच्छा अच्छा। पीसी 2 अलॉट हुआ था आपको? हाँ, सर मैं ये कंफर्म फाइनल जो है ना, ये मैंने 12 बजे मैं आपको कॉल करता हूँ सर एक बार। आपको सर वही पीएलसीएमसी ही दिया गया है, और पीईसी 2 बीटेक का। एमटेक का पीएलसीएमसी और बीटेक का पीईसी 2, यही 2 सब्जेक्ट दिया गया है सर। अच्छा। ठीक। अच्छा। ठीक, ठीक है सर, ठीक। ओके, सो एम आई ऑडिएबल नाउ?
Yes, sir. Yes, sir.
ओके, सो हाँ, तो we have seen how to calculate THD after the allocation of DG and D statcom. Now we are seeing harmonic source spectrum. So nonlinear loads in this case are placed at 3 buses, that is bus number 15 and 25 and 33. So, order of harmonics we have analyzed is 5th, 7th, 11th, and 13th and 17th. Okay, so the total load in terms of active power and reactive power connected is 4.63 megawatt and 2.873 MVR respectively for this case, and total active power loss is 221 kilowatt. The reactive power loss is 65.11 kVR, and the harmonic sources are present in these 3 buses 15, 25, and 33. The harmonic sources considered in this work are modeled in current injectors, and the data is taken in the spectrum as given in this table. So the active power loss, reactive power loss, and percentage TSD after DG and D statcom placement is recorded and is shown in this table. So active power loss is reduced to 113.71 kilowatt, after allocation of first DG, and after allocation of first and second DG, it is 84 kilowatt, and with simultaneous that allocation of both, it is 42 kilowatt. And similarly, reactive power losses has been also reduced as given in this table, and average TSD is 0.0669 742 after allocating first DG, and after allocating this both DG and D statcom, it becomes 0.06632. So due to extension in the power system network and increase in the use of power electronics devices, along with nonlinear load, has become the region for harmonic distortion in the power system. So this work presents the distribution system load flow and harmonic load flow for 34 bus system, as we have seen, and the percentage TSD obtained is reduced after that, and the voltage profile got enhanced. So next, after this work, that we will discuss what are the other DG and defects placement method. So if broadly, we will do a lot of researcher have worked on DG allocation area, but very few have worked for defects in the distribution system. So simultaneous placement of DG and defect devices in distribution is less, while fact and DG in the transmission system have been done by various researchers. So broadly, we can categorize allocation method in the four category, that is sensitivity based method, cost benefit analysis based, voltage security margin method, optimization based method. Okay, so sensitivity based method we have just discussed one method, and next is that cost benefit, voltage security, and optimization based methods are there. So various researchers have also shown that if we are putting DG, so uh, 20 to 25% of the grid, that addition of the renewable energy sources like wind energy can be enhanced. So it is reported that DStatCom can increase the wind energy based DG penetration capacity of the existing grid by 20 to 25%. Similarly, another researcher have also recommended that defect devices allocation can improve the that addition of renewable energy sources in the existing network only, and it will increase the active as well as reactive loading capability of the network. Okay, so with for all these four types of methods, we need to do the load flow analysis. So we know that what is the use or the necessity of load flow analysis means continuous monitoring the performance of power system, provide a systematic mathematical approach for determination of bus voltage, phase angle, and active and reactive power flow through different branches, generators, and load under steady state conditions. Used to find out alternative plans for future expansion to meet the increased load demand, helps in determination of the best location and optimal capacity of the generating stations, substations, and new lines. So most of the information of the system view of reactive power, costing, and pricing is based on load flow analysis. Load flow analysis is required to minimize the cost of meeting the load on a power system, and also it helps in keeping the device in power system within a desired operation range at steady state. And these range could be could include maximum and minimum output of DG, maximum kVA flows on distribution lines and distribution transformers, and maximum and minimum system voltages. So here load flow analysis or means load flow analysis very much required, and load flow analysis addresses steady state operation, not the transient or dynamic analysis. So this is the 6 bus system which already we have discussed, and how to do the load flow analysis, basic load flow analysis steps also we have discussed. Now cost is one important issue for enumerating the DG owner. We need to see the cost of the DG and as well as DStatCom. So energy loss we can able to calculate from this real power loss into time. So with the energy rate cost. So here annual energy loss cost we can able to determine by multiplying it with the hours of the year, that is 8760 hour in a year. So annual energy loss cost we can able to determine from this equation. Then we can calculate the cost of DG. Cost of DG can be calculated from this equation, which is referred from standard journal. So size of DG we can put it here after calculating the most favorable size from ourselves. We can put it here, and we can able to find the cost of DG. Then cost of DStatCom can be find uh, what is the average lifetime of the defect devices or DStatCom. We have to put it here, and we can find out the cost of DStatCom. So net saving we need to see. This is just one last that economic analysis we need to give, so that because if something is good but it is very costly, no will very less consumer will opt for that. Okay, so net saving means cost of energy loss before putting any devices. Then what is the net saving is that cost of energy loss in base case minus cost of energy loss with DG and DStatCom. What is the cost of that we need to minus it. Then we can able to find out the net saving. And here if we have done the reconfiguration, that cost also we have to take in the network, but in this case we have not done the reconfiguration. So next is that what are the other proposed method for finding optimal location. So one index I will explain it here for this StatCom placement. So say for example, this is the two bus system. One is sending end and another is the receiving end bus. Sending in bus voltage is Vm and receiving in bus voltage is Vn, and in between that Rx value is given Rm and Jxm. So load is given on both the buses and current flowing is Im. So Im we can able to calculate from sending in voltage minus receiving in voltage upon total impedance of the line. So from here receiving in voltage will be equal to sending in voltage minus current into the impedance of the line. So we know as apparent power equal to VI star. So I we can able to calculate. We have already calculated Im star. Also we can able to calculate from this way. Total power divided by VI star. So V will be equal to S by I star, or I we can able to say we can able to calculate from this. So I star will be S by V and I will be S by V star. So S star means P plus JQ becomes P minus JQ and V star will be there. So we can able to calculate IM, and after DStatCom placement, where actually DStatCom the reactive power it will give the compensate the reactive power. So QD will be minus here. So after DStatCom placement, this will be the net changes in equation number 2.8, and now the current will be as per equation number 2.9. So here the reactive power supplied by the DStatCom, by putting this value of IM from equation 2.9 in equation number 2.6. So we are putting the value of IM here, and after that we are rearranging it and separating real and imaginary part. We are getting active and reactive power equations as equation number 10 and 11. So rearranging equation 11 we can get because we are looking for reactive power allocation. So we are getting these equations number 12, and since it is a quadratic equation for stable operation, this b square minus 4ac should be greater than 0. So after applying this for stable load voltage, we get that this value for Rmn q1 minus q2 upon magnitude Vm sine theta z minus theta square should be less than equal to 1. So this is the reactive sensitivity index we have calculated, and after that we can plot it for all the buses, and the value of QSI should be always less than equal to 1 for stability. The bus with highest value of QSI is the most unstable bus and is selected as most favorable bus for D-STATCOM placement. So similarly, if we want to go for active power, so active power will be changed in equation number 2.9 instead of reactive power, and accordingly we can able to find out PSI. So it will show the active DG allocation, that where to allocate active. So QSI is plotted for 85 bus one rural radial distribution system data. From the data, we can calculate the QSI value, and it has been seen that maximum for branch number 68, we can see it is a maximum at the branch number 68, and which is the bus number 69. So see, at the 69th bus, we can place the D-STATCOM. So power loss index method for different buses are calculated using the expression given below. This PLI equal to this mg minus mn upon mx minus m. This is the another index method. We similarly we can find out the PLI value. For this, we need line and load data and perform the load flow analysis from the expression, plot the PLI values for the bus system we are analyzing. Similarly, various sensitivity indexes are there which can be plotted for seeing the most favorable bus where to allocate, and we can do this analysis for different load models also, for commercial, industrial, or jeep load model, or constant power load model, by following the similar steps. So after finding the most favorable bus, we need to put the devices and we need to find the most favorable size. So similarly, we can able to vary the size of the devices and record the losses. The size which is giving the less minimum losses will be selected as most favorable. So here one more thing is there. What is the impact of optimal allocation? So still we have not used any optimization technique. So instead of telling optimal, it will be better to tell most favorable size. So here say for example, two sensitivity index PLI and PSI is there. One is saying that it is good to place at 29th bus, and one is saying at 30th bus. So both we have plotted, and after that it is saying that D-STATCOM is 13 kVR is selected for by PLI and 1250 kVR by VSI. So accordingly, the impact of sensitivity index can be compared, so that with the minimum size maximum that minimum size maximum saving energy saving can be there. So that analysis we are doing it here. So optimal DG sighting and sizing, various techniques we have analyzed for various load models as per the power loss variations. So this is for both the load, all the load models we have plotted. So power loss variation with DG size for 33 bus radial distribution system is shown in this figure for constant power, commercial, residential, industrial, and jeep load model. So total power loss obtained after placement of DG is minimum at sixth bus for each loading conditions here, and hence selected as optimal location for DG placement. So we can use reconfiguration also. So reconfiguration means whatever existing network is there, whatever loading conditions will be there, that will be there, but we will reconfigure the bus to meet the load at each bus. So say for example, here a single line diagram of 33 bus system is given, and red line is say for example it is not there, and bus no, one bus is there from 3 to 23, 24, 25, and another is from 6 to 26, like that it is there up to 33, and another is the straight line 2 3 up to 18, and fourth one is that from bus number 2 to 22. So next is that whatever tie lines are there which will be connected here, and that will be switched on, uh, and reconfigure. This will reconfigure the system, and this dotted line will be break. Okay, so network reconfiguration, what we are doing, this is the switch numbers 37, 36, 34, 35, 33 is shown, and here this 32 and switch number 7, 9, and 14 is there. So in network configuration initially, this 33, 34, 35, 36, and 37 are open, and finally that this S7 in this figure, S9, S14, and S32 will be opened. Okay, and other will be closed. Okay, so this way also we can meet the power at each load, and but the benefit will be that it has been seen that without allocating any devices also, if we will reconfigure in this way, that losses will be reduced from 210 to 139, and voltage profile is also improved. Okay, so this is also one way to maintain the voltage profile of the network, and this will also lead to reduce the THD, and uh, after this we can also allocate DG and DStatCom with the reconfiguration. So this is the another network 69 bus system, and then with the probabilistic load model, as we have discussed earlier, we can compare the result of the various without DStatCom and with DStatCom. So we can able to see that losses are reduced from 243 to 187, and voltage, minimum bus voltage is also improved. Okay, so for each bus system we can have the results, and we can see that voltage profile of the network is increased with DStatCom. So similarly, annual energy saving can be also plotted with these methods, with various sensitivity methods. Then reconfiguration, with the reconfiguration we can allocate DStatCom. So we can have four cases without any reconfiguration and without DStatCom. Next case is that without reconfiguration and with DStatCom. Third case with reconfiguration and without DStatCom. Fourth case is that with reconfiguration and with DStatCom placement. So in all the four cases, we can have the result by taking the base value, base MVA of 100 MVA and base kV is 11 kV. So for 11 kV distribution network, this will be the result. So in the base case, when neither reconfiguration nor dstatcom is placed, at that time these losses are 317, and after that dstatcom case 2, after dstatcom placement, it is 210, and after reconfiguration it is 134, and if both we are doing dstatcom as well as allocating dstatcom and reconfiguration as taken, it is reduced up to 98. So this is the main advantage we are seeing here, and also cost of energy saving is higher with this dstatcom. So again, we can see the impact of higher bus voltage. If kV is 12.6 instead of 11 kV, so this will be the changes in the result. Similarly, we can see for all the other load models. So this is for constant current load model, constant impedance load model, and for the mix load model, we can have the results, and we can compare the cases. Okay, so with the existing results also, it can be compared. So all the four cases, we can see that for all the loading conditions, that with reconfiguration and with dstatcom, that voltage profile is higher compared to earlier one, and annual energy losses uh, annual energy losses are reduced, and cost of energy losses can be also compared and shown. This figure number 24 is shown the uh, comparison of cost reduction. So next, in addition to reconfiguration and dstatcom, we can add DG into the system. So we can have more cases with that, and we can compare the results so that voltage profile in each cases can be seen, and maximum voltage regulation for each cases can be plotted. So the results for all the loading condition has been obtained, and it has been recommended that that both simultaneous DG and dstatcom along with reconfiguration will result the maintaining of the voltage profile more superior, uh, in the superior way compared to the other technique, and it will result the TSD reductions also, and so next, the similar analysis we have done for unbalanced radial distribution system. Also the impact of light load conditions, similarly due to COVID-19, somewhere light load means industrial load are reduced, and this residential load are increased. So COVID-19 impact also can be analyzed with light load and high load conditions. Okay, so next is that for another technique is there, uh, how to calculate the economic dstatcom size. So here in this figure it is shown that as we are increasing the dstatcom size, dstatcom cost is increasing. So first red line is shown the dstatcom cost as we are increasing the dstatcom size from 50, 100, 150, 200 kVR. This size is increasing, dstatcom size is increasing, and accordingly dstatcom cost is increasing. One thing, and second thing is that as we are increasing the dstatcom size, the green line shows that cost means of energy loss. Okay, so energy loss, net energy loss is reducing, but after some times again it is increasing. Okay, so next, total cost if we are seeing, that cost of energy loss reduction plus including de-statcom cost. So it has been seen that total cost is minimum with de-statcom of 300 kVR. So de-statcom rating of 300 kVR is installed as per the cost analysis mentioned above. After installation of de-statcom, 300 kVR reactive power is locally supplied in each phase, thereby power taken from the substation reduces. So this is the analysis for phase wise for the unbalanced radial distribution system. So here that in each phase losses are shown that for phase A 51.44, for phase B 54.053, and for phase C 40.947, and with this STATCOM allocation of 300 kVR on each phase at bus number 15th, so it is reduced up to 41.241 compared to 51 earlier. So overall 146.442 including all phases is reduced to 117.052. So this kind of loss reduction will result in the improvement of voltage profile and overall net saving of the energy. So these are the voltage profile after implementing DG and D-STATCOM. So it has been improved for all the power factor we have considered for the analysis 0.85 or 0.9 power factor. So we can see clearly the improvement in the voltage profile after allocation of DG and D-STATCOM, and annual energy saving can be also seen. And after that, reactive loading capability and active loading capability can also be seen, the enhancement of active and reactive loading capability with installation of the reactive devices. So it has been seen that the improvement in active as well as reactive loading capability with installation of the devices. So with this, we came to the end of the today's this presentation. So the overall conclusion is that the defect devices can play a vital role in improving voltage profile and reducing the losses in the system, thereby increasing annual energy saving in the distribution system. Power loss increases with load growth. Accordingly, the required D-STATCOM KVR support also increases to meet the load growth. Annual energy saving obtained due to energy loss reduction is higher with load growth after installation of D-STATCOM. After reconfiguration, the distribution network, uh, the power losses are reduced and with the enhanced voltage profile for all types of load models, including nonlinear, and TSD will be reduced. So it can be observed from the results also that the power losses are significantly reduced with simultaneous placement of TG and D-STATCOM. So significant released feeder capacity is also recorded with the simultaneous allocation. So the study will help network operator for better asset utilization with optimal allocation of TG and STATCOM for energy efficiency improvement into the system. So thank you everyone. These are the major references which is used to study this topic and for the getting various data. So thank you everyone.
Thank you, sir. Can we take any queries from the participants, sir?
Yes, sure.
The participants, if you have any queries, you can ask.
So Dr. Anil, if in case no query is there, we can stop. Or participants are can contact me over email also. in
Okay.
future also if they are getting any doubt or any question in this session.
Okay, okay, sir. Thank you, sir, for an informative session. You have explained about DG and DFAC devices, load modeling aspects, harmonic load flow analysis, optimal location sizing of DG and D statcoms, economic cost analysis, and many more points in a very short session. Your session will be of great help for the researchers and all the students who are participating in this event. Thank you, sir, for joining us, and thank you very much.
Thank you. Thank you, Dr. Anil, for providing me an opportunity. And thanks to Dr. Minal Kanti Sarkar for contacting me. So thank you everyone.
Thank you, sir.
Thank you, sir. Thank you very much. Thank you, sir.
I would request all the participants to stay connected as there is some technical issue from the search side. So we're trying to rectify that. So please remain with us for some more time. Good afternoon, sir. Sir, good afternoon.
Hello, Anil.
Yes, sir.
Sir is trying to join. Actually, he unable to listen.
Okay, okay, sir.
Hello. Yes, sir.
Okay, can you see me now?
Yes, sir.
Okay, wonderful. Thank you.
Good afternoon, sir. Yeah,
Good afternoon.
yes, sir. Sir, I welcome you to the FDP program on recent trends of control systems in power electronic converters. It's my pleasure to introduce Dr. Ashish Johari, sir. Sir is Principal Consultant Synergy HR, a former professor of medical human physiology and management in HR area. He is a versatile behavioral training and HR consultant for various corporate business houses and training and development institutions, both government and non-government. He is certified from various national and international level reputed training organizations. Sir is a graduate in medicine and holds a PhD in business management, specializing in authentic leadership and emotional intelligence. And he has a total of 20 years of experience, out of which 15 years of experience are exclusively has been in the field of HR and behavioral training and consultancy. He is co-author of a book for MBA curriculum of Rajasthan Technical University. He has published several research papers to his credit in reputed journals. He trains extensively on personal excellence, authentic leadership, and team building, emotional intelligence, NLP, positive physiology, and some of his corporate clients are HP, HCL, Xerox, Nokia, Cipla, Honda, TVS, and many more to count out. He is certified trainer from internationally renowned Dale Carnegie and Associate, certified trainer on DISC personality assessment tool from John Wille and Sons, certified NLP practitioner associated with American Board of NLP, certified emotional intelligence professional from Qualia Emotions Institute, France. Sir, with this brief introduction, I would like to hand over the session for further proceedings.
Kumar Bonella, is that correct? Can you hear
Yes,
me,
sir.
friends?
Yes, sir, I can hear you, sir.
Okay, thank you so very much for that elaborate introduction, and I must apologize to the audience. There has been a how shall I put it? unprecedented power failure at my end. So, as you can see, I'm just trying to make things work. I've been waiting for the power to come in, and that was the reason I kept you waiting. I'm so sorry for that. Please bear with me. It's a pleasure. It's a privilege to be talking to all of you and being a part of this AICT at FDP. Thank you so much for the generous introduction, dear friends. Very happy to be here. Very happy to see all of you, be here with all of you. And all right. So I'd like to take you through a brief about what we do and the company that I represent, Synergy HR, dear friends, it's a people development company. We apply research in human behavior to uh, make people better versions of themselves. And in this context, we work with lot many organizations, be they government, non-government, corporates, and so on and so forth. So emotional intelligence has been one of my favorite areas, and relating emotional intelligence with stress management has been the bane of today, the word of today, and that is what we would be talking about. So if I can just have idea about the people who are in, uh, great. Can you see me? All right. I must have put something. I'm not able to see you, dear friends. Can you see me? Yeah.
Sir, your video is not there, sir. Your voice is audible. Now,
Okay.
now it's okay, sir.
Okay. Now I can. Please bear with me. Anything that can go wrong has gone wrong today. And ironically, today is the session on stress management, and I am under. Yep. All right. So I was just saying that today is a session on the stress management, uh, and it has been day has been testing my stress levels since it has started in the morning. So if I can just have a idea about the people logged in from different locations and what kind of background they carry, it would be great. So if you can just let me know which location you are from, you can unmute yourself and let me know which location you are from, dear friends. Quickly, just within a few seconds.
Sir, do you mean all the participants who are here, or
How many people do we have here right now? How many have
right
joined
now
in?
around
I'm not able to see on the.
right now around 56 are there, sir.
Hello.
56 are there, sir. 56. Around 56 participants are there, sir. Right.
Anil sir, I'm not able to hear you.
Uh, I can hear you, sir. Around 56 participants, sir. Now, is it audible now? 56 participants, sir. Hello.
Hello.
Yes, sir. I can hear you, sir.
Yep, I can hear you now. How many
Yeah,
participants do we have?
around 56, sir.
56. Oh, wonderful. That's a wonderful number. That's a wonderful number. Tell me, do you have any chat options here?
Yeah. It's there, sir.
There. Hmm. I'm not able to see on the phone. Oh God. All right. So, dear friends, I wanted this. when you talk about stress management and stress, the world of today has been a receptacle of stress covering in all our lives, from all corners. Can you give me a moment? I think the power is back, so it won't. Please give me a minute.
Okay, sir. Okay.
I'll try to log in from the laptop. It's join meeting. Yes. Give me a minute. Just bear with me.
Oh,
Be
okay, sir.
easy
No.
for me to. I think I'll be able to. No. I wonder why. All right. Friends, I had prepared a presentation for you, but I'm sorry. I'm trying to log in from the from my laptop, but it is not working. And WebEx being a WebEx, whatever it is. So I'll just try to cover up whatever I have tried to put in, and let's see. And if you have any queries, if you have any questions, please feel free to unmute yourself and share your views, share your points, whatever it is that you might want to ask. If you look at the word of today, overworking is the black plague of 21st century. Yes or no?
Yes, sir.
And that has led to what is known as the lifestyle diseases. There has been a revolution in the medicine concerning how we think about the disease that has been affecting us. It involves recognizing the interactions between the body and the mind and the way in which emotions and personality can have a tremendous impact on the functioning and the health of virtually every cell in the body. I believe all of us here are friends from the academics industry, if I'm allowed to call it an industry, or from the academic background. Most of us are professors, associate professors, or assistant professors. Nevertheless, they are all members of the teaching fraternity. And teaching fraternity is one fraternity which bears the brunt of the maximum brunt of stress. They are one of the most highly stressed out have when you talk about stress, medical community takes the credit, doctors are very highly worked, forces, government officials, everyone except the teaching community. Whereas the fact of the matter is that and s- suddenly and sadly, the word around the teachers has changed. Ever since, of course, for the past 2 years or so, when you have witnessed when the pandemic has struck, things have gone in a very different trajectory towards teachers, and it involves teachers from all levels, all hierarchies, whether it is school going teachers, college going teachers, higher education teachers. And that is how it becomes pertinent. It becomes relevant for uh, for topics like stress management to be included in the teachers' circles, so that we understand what impact it carries. Of course, we are familiar with the term. We are aware of what stress is. But if I ask you, what are the sources of the stress? From where do you get the stress? What would your answer be? Let me just ask you to this. What is, if I ask you to name one single largest source of stress, what would your answer be? Is there anyone out?
Expectations.
Sorry?
Expectations.
Expectations. Expectations of whom? From whom?
From our surroundings and from our family and looking at others, feeling like why I'm not like him.
Okay. So is it about? Could you please go deeper? Could you please elaborate deeper on this?
Means now generally what happens for the students and mostly for the, like I'm talking from students perspective,
Mhm.
it's like there's a competitive thing going on, like you are stressed so much that you have to reach to the peak somewhere, but it doesn't happen with everyone.
Mhm.
Everyone has his own limitations, so
Hmm.
that mostly is faced by the students.
I'm
But the thing
thankful to
is,
you for your input, Anil sir, and I'm really, really grateful to you for multiple reasons. Reason number one is you chose to speak, so at least we are having an interaction, and you can understand how difficult it is for me to interact through a small screen of a mobile. I'm grateful to you for having responded back, and for the benefit of all of us, may I know which department you are from and which location you are from?
you're talking myself, sir? Yeah.
Yes, I'm talking
Yeah.
about you,
I,
Anil.
I am from Visakhapatnam, sir.
Okay,
Now I'm from analytical department. Like I'm a PhD scholar in analytical department.
wonderful. So you say regarding the students, this feeling of competitiveness, that is the source of stress. But this feeling of competitiveness is something that has made us survive on this planet. Yes or no, Anilji?
Yes, sir.
So if feeling of competitiveness generated stress, then stress is something that has made us survive. It is essential for our life. Then how come it has got such negative influences? Are you understanding what I'm trying to get at?
Yes, yes, sir.
What would your answer be? If you can, if you can, switch on your video, it would be great. If people can switch on their video, those of us who can are comfortable, if they can switch on their videos, it would be really great.
Yes, sir. Like the thing is that what happens is that like everybody has his own limitations. Like if
Mhm.
somebody says that he did so well, like what happened with you? Why can't you be like him? He
Mm.
reached to that milestone. You're still in here. So
Mm.
those things are because now if in the earlier days the options were limited.
Hello, can you hear me?
Yes, sir. Now it's okay, sir. Right.
I'm sorry, it keeps coming and going. I don't know what it's. Yes, yes, please.
That's what, sir. Like, means everyone has own limitations. Like expecting, like nowadays, whatever so many opportunities coming up,
Mm,
and new avenues have opened up. So
mm,
then, like, there are things like you feel that I can have done that, but
mm,
why I'm here. So those things always run in many people mind, because I know my friends in and around, so they
mm,
speak like that. Like,
mm,
why I chose this, why not that? That gives this gives this. So like that kind of a thing is there. Of course, in our workplace, that is the stress that is quite obvious, because that's not
mm,
a like thing that is like everyone has to handle that.
mm,
But for an student, especially, like I'm talking about, like who just graduated from their from who had just finished the graduation, they like then they wait a few hours in selecting their career.
mm,
During that time, like they have a lot of questions in their mind, and they choose one path, and they when they move towards the path, and they find that toward the end, like I chose this a path where it doesn't give me that much of like satisfaction, maybe in any terms. Like if I had chosen that path, it would have given furthermore satisfaction. So, such kind of things, maybe that also adds up for me. What I'm talking about in and around, like I don't have the others, but I know the people whom I know around me.
Thank you. Thank you so very much. And it's a very important input. And the condition which you just shared, and the situation which you just shared, I believe that is a situation everywhere with lot many of us, perhaps almost all of us. We do something and then we wonder why we have done it. And then we see somebody else doing it and we find him to be happier than us, more successful than us, and then we are miserable,
Yes, sir. Yes, sir.
isn't it?
That's what I actually tried. That the point which I want to actually stress on, that like I just elaborated, you just in a said in very short.
Yes, indeed. And if you look at it, look at the irony of it. I mean, you are a PhD scholar. You would have worked very hard to reach this place, and pursuing a PhD is a Herculean task. I understand that. All that, burning the midnight lamp, burning the midnight oil, working hard, sacrificing pleasure, sacrificing leisure, sacrificing friends' time, and all that time. And then when you get it, after some time, it wears off. The novelty wears off. There is someone who is happier than you, more successful than you, making more money than you, and you feel miserable. I mean, when I say you, I don't mean you per se, but that is the story everywhere.
Yes, yes, yes.
So, what do you think is the issue there? What do you think is the source of the stress there? That is one situation, Anil. Thank you.
Yes.
I can call you Anil. Will that be fine?
Yeah,
Anil?
yeah, yes, sir.
Yeah.
Yes, sir. Yes, sir. Definitely, sir. Yes, sir.
Yeah. And please call me Ashish. That's okay. Don't go by my white beard. Okay. Lovely. And if there is anybody else who would want to, pitch in and who may want to join in, please feel free. And as regards, I hope you're comfortable with the language. I can speak English. I can speak Hindi. If you want me to converse in English, I can do that. If you want me to use a mixed version, please feel free. Please let me know, and I'll switch to a mixed version. I can use Hindi and English interchangeably, depending upon your choice, dear friends. So I'd like to talk about two fundamental aspects when I talk about today's session. One, of course, is what stress does to us. How does the stress happen? What is the impact on the body? All right. Second is what we can do to handle it, to change it, to tolerate it more. One of the buzzwords that is running across all circles, whether it is medical, whether it is non-medical, whether it is general, we are in agreement that stress has permeated, has entered into all facets of our lives, ranging from a pre primary kid to a person advanced in age, nobody is free from stress. Would you agree with me or not?
Yes, sir.
Yes, sir.
Yeah. Thank you. I heard few voices. That is very encouraging. Okay, I see Gaurav.
Yes, sir.
Gaurav. Yeah. Gaurav,
Yes,
where
sir.
are you from? If I
Sir,
can ask
I'm
you.
from Lucknow, sir, and I'm also a PhD scholar from DTU.
Oh, oh, from Delhi Technical University, is that
Yes,
correct?
sir. Yes, sir.
तो लखनऊ में कहाँ रहते हैं आप, गौरव?
सर लखनऊ में सर मैं इधर अगर आप गुरु गोविंद सिंह स्पोर्ट्स कॉलेज के पास
कॉलेज
टेढ़ी
का नाम
पुलिया
नहीं,
के
लोकेशन
पास।
बताओ। टेढ़ी पुलिया,
हाँ,
यस सर टेढ़ी पुलिया।
अलीगंज के पास।
यस सर अलीगंज के पास
हाँ,
जानकीपुरम।
समझ गया।
यस सर।
जानकीपुरम, ऑफ कोर्स, सेक्टर क्यू के बाद।
यस सर।
बहुत खूब।
सर आप यहाँ पे आए सर?
Oh, I'll talk about that later,
ओके
Gaurav.
ओके
Talk to
ओके
me.
सर।
Wonderful to see you. So you see, I'll be talking about what stress does to us. देखिए, all of you are from technical background. You would have studied physics. You would have studied about a property called stress. It is the ability to retain the shape when the system is put under some kind of stress, some kind of tension, isn't it? That is a layman's understanding of what stress is. So we talk about elasticity, we talk about those kind of physical properties of physics, and then that is where we stress. So whenever a system is put under some undue tension, undue stress, that is when we study it. Is isn't that? So stress is a situation which is characterized by non-equilibrium. So whenever a system is disturbed from its position, the system comes under stress. Am I correct? Do you agree with me?
यस सर।
That happens in physics. That is how what we studied. But if it applies to humans, if it applies to our lives, अगर ये हम अपने ऊपर देखकर सोचें, so what is that equilibrium that we are talking about? And what is that disturbance that we are talking about? Equilibrium is a constant state. Let's say, for example, you are living in, let's say, Lucknow. Gaurav is staying in Lucknow. It is winter time, or abhi temperature is somewhere around 20 degree. Let's say this. So 20 degrees Celsius or 18 degrees Celsius is a temperature that calls for mild winters. Maybe Gaurav can um, have a pullover or a jacket, and things will run. Suddenly the weather changes. What happens? There is cloud, there is depression up in the air, and there is rain coming. The temperature dips further. When the temperature dips further, the it becomes colder, and now Gaurav is sensing a trouble. Same way happens when there are summers. In our lives, things are moving well. Things are moving. We have fallen into a kind of routine kind of thing. We wake up, get ready, go to our institution, do our work, come back. Suddenly, what happens? There is this corona thing coming in. And what happens when corona comes in? The colleges close down, the libraries close down, the markets close down, everything closed down, and we shift immediately, almost within no time, from offline teaching to online teaching. What has happened? Equilibrium has been disturbed. Our routine has been disturbed. And suddenly you have news channels, coming in, flashing scenes and pictures and stories of depression, of death, of disease, everything. What happens then? Your mental peace gets robbed, your mental equilibrium gets disturbed, you are under stress. Do I make some sense here?
Yes, sir.
Yes
Do I
sir।
make some sense here? So if you look at it, anything that disturbs the constancy, the equilibrium that you are in, the comfort level that you have adapted with your surrounding, anything that disturbs that is a source of stress for you. how does the body react? So if I ask you, whenever you have been in stress, uh, what have you felt? What has happened? What have you felt? How would you describe it? Or if you have seen someone in stress, or if you have met someone who is in stress and who has described his or her condition to you, what how would they uh, describe it?
So when I am in stress, then all the work that I am doing, or all the work that I will be doing, that all the works are get affected by that. Let's suppose that if I have to prepare for my test, or prepare for my viva or something, if I'm in stress, then that preparation would not be as good as it would be without stress.
Why
And
what happens? What happens
uh,
if you can, if you can just reflect and can just describe?
because
What
sir,
do you feel?
in stress, that the percent of concentration what it would require for a on a particular situation,
Hmm.
that is not there. Basically, sir, it get switched to anything else, and it continuously thinking about that point for from which I've got stressed, or something had happened. So let's suppose that some matter has happened in my family, and
Mhm.
I'm preparing for my exam. So
Hmm.
and I have been stressed because of that.
Hmm.
So continuously I will be thinking about that, and that would affect my preparation.
Hmm.
So
Have you noticed what changes it has on your body? Have you ever
You
yeah,
noticed this?
will feel a,
yes, sir. It something that we are that
Hmm. Carry on.
you will feel a sense of anxiety, sir. Anxiety.
When you have a sense of anxiety, how does it look like? How does anxiety look like? I mean,
It seems
what it is that, can you describe that condition? Uh,
first in terms of physical body so, impacts, it would be like your gastric levels will increase. The first thing,
mm-hmm.
your body starts producing more gas that you can feel. You feel like your your stomach getting
Oh,
that
you
side
feel
of
that.
feeling.
You
Yeah, I
feel that.
feel that.
Okay. Okay. Good.
Uh, that's what I think. That is one kind of an thing that generally I think I seen my most people saying that, like when they are in this condition, they feel that I'm feeling something like stomach is like, so that is one thing, sir. And that is, I
headache.
think, that one aspect which I think it happens.
Okay. And
And sir, headache.
headache. Who said headache? Gaurav? You
Yes,
have
sir.
said headache.
I've seen.
Headache happens.
Yes, sir.
Okay. And
And
what else? Have you ever tried to find out, or have you ever tried to understand why it happens? Yeah. Give me a minute. See, whenever we are under stress, whenever when I was talking about this equilibrium is disturbed, whenever a situation throws us out of balance, the first thing, if you notice, if you've been aware, if you've been conscious, is your breathing starts getting faster.
yes, sir. Yes.
Your heart beats faster. If you see, your you can detect a certain tension in your muscles. You see, Kavi, if you notice, you if you've been aware, you will find that your fingers are clenching. Clenching, you understand? They start contracting. ऐसे मुट्ठी बंदनी शुरू हो जाती है. Your biceps start contracting. Your muscles, you can feel the tension in your muscles. Your eyebrows, they come closer. You start looking with fixed eyes. Your facial muscles, they tighten, they gripen. You become alert. All these changes happen when you are under stress. Am I correct?
Yes.
And you know why? You see, there is something that the nature has given us, and it is called the nervous system. And it is this nervous system that has enabled us to survive, to become the dominant species of this planet. The nervous system works the same way as a computer system. What is a computer? A computer is an input output device. So you feed something, you get a response. It's the same way with the nervous system. The nervous system receives input from the environment and it decides it decides the responses that we are going to give so that we are able to exist in our environment. The reason why human beings are the most dominant species is that they have the most advanced nervous system that has been created. And why? Because in here, in our skull, is the largest storehouse of information ever created in this universe. We call it the brain. Your computers have memory, your phones have memory. The brain also has memory. And what does it store in that memory? It stores information. It has got certain centers which decide our responses. So what happens is that the same reactions that happen today which create stress, it is the same reactions which enabled us to survive in earlier times. There are centers in the brain, right where your forehead is, right where your forehead is, there is something known as the prefrontal cortex. इसके बिल्कुल पीछे जो brain का हिस्सा है, that is known as the prefrontal cortex. Or deep inside the brain, there is a structure known as the amygdala. Amygdala, what does it do? That is the fear center. So, whenever the amygdala is activated, we start experiencing fear. When does amygdala get activated? When do we experience fear? आपको डर कब लगता है? When do you experience fear, Anil? When do you experience fear, Gaurav?
Sir, then fear can be described in some types, because fear can be any phobia also, and fear can be
Oh,
the
yes.
outcome.
Yes.
So,
So when do you feel? When do you fear? When do you feel fear? It's a general question. I'm just asking you.
when we know that some results are coming for the exam,
You don't fear the results, Gaurav. You fear something else.
When we see something we are going to lose, it can be anything, and then the fear automatically gets in.
And don't you find it funny, Anil, that when you see something you are going to lose and you have yet not lost it, you don't know whether you are actually going to lose it, but the anticipation of losing it makes you afraid. Yes or no, Anil?
yes,
Yeah,
yes.
yes, yes, sir.
Yes, sir. Yes,
So
sir.
it Oh, I hear some other voice. Is that Vijay Lakshmi?
Yes, sir. Yes, sir.
Thank you so much for pitching in, for joining the discussion. Thank you so very much. I'm so grateful to you.
Thank you, sir.
If you are comfortable, please switch on your video. As it is, I can only see 2-3 faces because I'm logging through a mobile. So I'll be really grateful to you. It will give me the sense of talking to people instead of talking to a screen.
Okay, sir.
Thank you. Oh, wonderful. Thank you, Vijay Lakshmi. Where are you from, if I can ask?
I'm from Tamil Nadu, sir.
Oh,
I'm
wonderful.
from
Tamil
Trisha
Nadu, which
Engineering
place?
College.
Tamil Nadu, which place?
Chennai, sir.
Chennai.
Chennai.
Okay, great. Your voice is breaking. Anyway, so we fear the uncertainty. We see the brain is designed in such a manner that it seeks patterns, it seeks continuity, it seeks certainty. That is how the brain has been designed. The moment there is uncertainty, the brain, switches on the alarm signals. If you know you will pass in your viva, will you study? You won't. None of the kids would. None of the school children would. You would not. Suppose you call me to your house for lunch, Vijay Lakshmi,
Yes, sir.
and
Always welcome, sir.
and you keep wondering, should I feed him with sambar? Should I feed him curd rice? Should I feed him idli? Would he like that? There will always be a what shall I say? Consternation. You will keep thinking, and you will keep you'll be in stress. As a matter of fact. But if I tell you, yeah, but if I tell you, Vijay Lakshmi, I love South Indian, feed me anything, and then you'll be relieved. Oh, that's my specialty. I'll feed him the best. I'll make sambar with the homemade masalas, and he'll enjoy. So what has happened here? The uncertainty has given way to certainty. It has given you control, and it has relieved you of the stress because the brain is now released. But suppose if I ask you to cook a hardcore North Indian dish, which you have not prepared before, what will happen? You'll be back to the same stressful condition. Oh my God, how can I do that? So the brain wants to see certainty. Wherever there is uncertainty, the brain is under stress. I'm sure you would have kids, many of you. You want your kids to do well. So you are after their lives. And you have no idea of knowing, no way of knowing where they will end up. They may end up in all probability better than you because you ended up better than your parents. All of you. And yet, what do you tell them? You're not studying properly. I don't know what you will make in your life, what you will do in your life. And what? They are kids. Standard first, standard two, standard three, fourth, fifth, maybe. You see? And we lie awake in the night thinking about the future of our kids, having no way of knowing where they will end up. And yet we keep telling, see, the neighbor's son is doing so well, my kid is not doing well. Pata nahi kya karega. He's only securing 90% marks. The other fellow is securing 95% marks. He won't get good admission. Imagine that. The problem is not in he or she not getting admission. The problem is the uncertainty. Your brain perceives the uncertainty, it gets stressed. And what happens? When the brain perceives that, it creates a chain reaction in our body. Because the brain, understand what has happened. This nervous system that we are talking about, this brain that we are talking about, It has been with us for millions and millions of years. We evolved from primate, from monkeys to human beings, isn't it? So the nervous system was already there. But what has happened is in the past 4,000 to 5,000 years, there has been a drastic cultural evolution. So we find ourselves living in a space with a apparatus which was designed to protect us 1 million years back. You understand what I'm talking about? What I'm saying is that the reactions that we are programmed in, those reactions protected us 1 million years back when we were living in forests, when we were cavemen. But now we don't need those reactions. Nevertheless, those reactions are there with us. And that is why when they are activated, we face a stress. Imagine if we were having this FDP 1 million years back. Let us take a travel. Let us travel through time. And I take you 70,000 years back, 80,000 years back. And we are having a AICT at a FDP like this. What do you think we would be discussing? We will not be discussing emotional intelligence, stress management. We will be discussing how can we kill a larger animal? How can we plant the new crops? Because we'll be sitting in the open nature. Understand? And one sound from the forest and our senses would be alert because it could have been a predator trying to attack us. And it will not give us time to react. So the brain has to be active, very responsive. This is how we evolved. Fear protected us. If we were not afraid of the tiger, we would go and pet it. We would pull its ear, we would play with it, and what will happen? The tiger will eat us, we'll be lost. So amygdala evolved. Emotion called fear evolved to protect us. But we don't need that fear now because we don't have tigers coming in. But what happens? I am in the same department as Anil. I see Anil going 3 times into the HOD's office, and what do I feel? I feel this guy is poisoning the ears of the HOD against me. You see, he's been feeding him stories. So he'll get promoted before me. This fear turns into jealousy, turns into politics, turns into everything conceivable. And why? Because my amygdala has been overactive. And the impact on me, because my brain has sensed a threatening situation, it will prepare me with the same reaction it would have done if I had been 80,000 years back. So what will it do? It will increase my heartbeat. What will happen if my heartbeats are increased? My heartbeats are increased. It will ensure increased blood circulation to my muscles. It will also break down the stored food. My sugar levels will increase because sugar is a source of energy. Glucose is the source of energy. So the brain senses that this man might need more energy, so the glucose levels will increase. The stress hormones will increase because the stress hormones prepare the body for a stress situation. Ironically, this is not a stress situation. This is something that I have thought, I have conceived, I have interpreted in my own body, in my own mind. The reality might not be true. But look at the impact it is having. So persistent, consistent elevated glucose levels, what happens? It develops insulin resistance and predisposes us to What? Diabetes. And that is why India is the diabetic capital, if you look at it. Because we are genetically predisposed and we are lifestyle wise. Increase in the cortisol levels mobilizes, results in the breakdown of complex food products. So, heart disease is because the heart is continuously pumping a lot. So, from the top to the bottom, it has its impact on every single organ. That is what stress does to you. There is one more thing. Let me also, put it this way. How stress impacts us. Let's say, for example, um, you you have people like you are engaged in one task. Let's say you are organizing an FDP like this. Okay, so your entire attention is here, focused here. Or if you are writing your thesis, your entire focus is on writing the thesis. At that point of time, do you care for any other task? If you have a class to take, if you have an extra class to take, you try to postpone it. If you have to visit your some family function, you postpone it. Isn't it? That is what we do. Why? Because our energies are directed to this more important task. Similarly, when our body is under stress, the entire responses of the body are directed towards this stress, towards which this stress response is directed against. So, with the result, all other actions and functions are compromised, are reduced. Functions of immunity, functions of repair. You see? So, the body repair system, it goes down. The body's immune system, it goes down. When the repair system and immune system goes down, the body becomes susceptible to damage, susceptible to other infections. Somebody mentioned that we have headache during stress. Now, what is the correlation between stress and headache? And it is a common problem, sadly unnoticed. Nobody pays any attention. The females of our house, they keep complaining, I have a headache. And what do we tell them? Are tumhara to natak hai. This is a drama you are faking. You just don't want to, you are lazy, you don't want to do work. And this we tell to the woman who has been working 16, 17 hours every day without a leave. Especially someone who's working and also has a family to manage. And that's the story in every household. And when then such a lady comes up and says, I have a headache which has been plaguing me for the past 6 months, nobody pays any attention. Are headache hai? You take a medicine. Headache hi to hai. There is a reason why there is a headache. I told you, the muscles are in a contracted state because they are ready for action. The flight mechanism, the fear, fight, and flight mechanism. If you ever notice, when you are under stress, your these frontal muscles, we call it occipitofrontalis muscles. Your eyebrows would be like this. And when you do it, contract your eyebrows like this, it creates a tension in the muscles here. Persistent, prolonged contraction leads to headache because the muscles pain. Sad story. Tell me if I'm wrong. Have you ever noticed suddenly in your cities there is a large number of fertility clinics that are coming up? This was not the case 30 years back. Have you noticed this? infertility cases are on the rise. And why I'm bringing up this in a forum like this, because it's something which is a cause of concern. The entire hormonal axis has been disturbed because of the stress. And this stress is of the lifestyle that we are leading. You go to bed late, you wake up early, and from the moment you wake up, you keep working. There is no respite. Males and females alike. There is no respite. There is no emotional outlet. There is no physical outlet. There is no mental outlet. If you are free from taking classes, you have admin loads. If you are free from one admin role, you have three other admin roles. If you are free from your admin roles, you have research paper writing pressure. If you are free from research paper writing, you have some other things. And one very dangerous trend has come up in our academic institutions, and that is the more, the person in the higher leadership position is considered to be a more effective leader if he makes the department work harder and harder and harder. So all these things are contributing to the stress. Do I make some sense here? I've been speaking for very long.
Yes, sir.
Yes, sir.
If you talk about the students, same story, same format, same template. Whether you talk about friends, family, anybody, people are waiting to to give vent, give steam to what they feel. That is how the word of stress is operated in. So, what is the respite? What is the solution? What can be done?
Meditation.
Sorry?
Meditation.
Meditation. But not everybody goes in for meditation, isn't it? And what does meditation actually do? How does it help? Is it only a fad? You may believe in meditation. I may not. Is there a genuine correlation between meditation and stress relief? Is there anyone else out here who would like to contribute? I would love to listen to your views, dear friends. All right. So let me give you a perspective here. There are two structures in the brain specifically which I would like to talk about. I wish I had the presentation with me. I could have shown you on the, it's there in the presentation that I prepared for you all. And I hope when you see the copy, you'll get an idea of it. I spoke about two centers. One was the amygdala, another was the prefrontal cortex. Prefrontal cortex is just behind your forehead. Amygdala is somewhere deeper. Amygdala is the center, is the structure which is concerned with the perception of fear. So whenever you are afraid of something, whenever you feel fear, it is because your amygdala has been activated. Now, amygdala works in close connection with the prefrontal cortex. The prefrontal cortex here is the executive center of the brain. It is concerned with the decision making, the logic. There are extensive connections between the prefrontal cortex and the amygdala. So both work in unison, in synchronization. So whenever amygdala gets activated too much, it is the duty of the task of the prefrontal cortex to quieten it down. So this resilience that we talk about, this emotional resilience that we talk about, because why we are talking about emotional resilience? Because if you look at it, fear is a very powerful emotion, and stress is the resultant when we feel fear, when the amygdala is activated. You see? So emotional resilience would mean that this this exorbitant perception of fear has to be toned down, has to be balanced, has to be brought down. Are you able to hear me? If you are able to hear me,
Yeah. Yes, sir. Yes,
yeah,
sir.
yeah. Okay, good.
Yeah.
So emotional resilience would mean calming down the amygdala and moving ahead with the prefrontal cortex. The problem with us is that we start fighting with the emotion. We have been taught that way. क्या सिखाया गया है हमको? गुस्सा आए तो बर्दाश्त करो. डिप्रेशन में हो, नेगेटिविटी आ रही है तो think positive. If you are feeling sad, frustrated, anxious over something, don't think about it. That is what we have been talk about. We have been told to do, isn't it? A new thought says, allow yourself to feel that emotion. Allow yourself to experience that emotion. Because till the time you will keep struggling and fighting that emotion, you'll create a stressful situations, conditions inside your body. You see that? Our brain and the body, or the mind and the body, have a reciprocal um, connection. You see, both impact each other. The mind or the brain impacts the physical body impacts the mind. Whenever you are worried, look at your body language, look at your body. Whenever you are stressed out, have you ever taken a note of your body? It feels lethargic. It feels as though there is no energy left. It feels as if the body is incapable. You don't feel any tightness in the body. It's lethargic. But when you are happy, look at the energy you feel. Look at the zeal. Look at the enthusiasm you feel. So your emotional state impacts your physical body. So if I am under stress, which means I'm feeling it here, and I'm feeling the impact on my body, what can I do to reduce that? I can work on my body and thereby reduce it here. Does it make sense or not? Does it make sense or not?
Yes, sir. Yes.
So that is the reason why doctors advise mild exercise, walk, regulated diet, regulated lifestyle, because by doing so, what you are doing is you are ensuring the physical well-being of your body. When the physical well-being happens, it impacts your mental well-being. I don't know how many of you have done it, but try doing it, practicing it, and you will feel it. Go for a walk, a morning walk, and leave your phone behind. Don't take your phone with you. Don't take any distraction with you. Just walk like the olden times and watch the effect and the impact it has on your body. All these practices, I'm sure you would be subject to it a lot more than what I can tell. They are directed at making the body more less susceptible to stress. They're working on the body. So mild exercises are like that. Yoga is like that. How does yoga help? Yoga help because when you do yoga, it creates a suppleness in the body, which regulates the hormonal axis, which quietens down the amygdala, and you feel relaxed. If I ask you to do that, you'll tell me, sir, I don't have time. Why you don't have time? Because in your mind you are thinking you don't have time, you don't have time. As a matter of fact, if you just notice, if you just for a moment just be into the moment and think where your time is going, you will find that there is a sizable number of tasks that you can do away with, which are non-important tasks that you are engaged in. You can already, nobody's asking you to compromise, nobody's asking you to leave important tasks. But the non-important tasks, which consume a sizable chunk of your time, you can easily do away with and invest that on your body. When you do that, the entire hormonal axis is going to be reversed. Do I make sense here?
Yes, yes.
You spoke about, somebody spoke about meditation. How does meditation help and what is the correlation? See, when you do meditation, and there are so many ways, there are so many schools which are proposing this. There is scientific evidence how meditation is impacting or is resulting in the reduction of stress. So I had told you, we had discussed that when we are under stress, when this amygdala is activated, there are centers in the brain that get activated. The breathing rate goes up, the heart rate goes up, the glucose level goes up. What does meditation do? Every meditation results in a quietening influence on the mind. So, when you sit with your closed eyes, you focus on your inside, there is a quietening effect on the thoughts. You become disconnected from the surrounding words. When there is a quietening impact on the thoughts, your emotions also, the surge that you have been facing, it goes down. If you notice in the meditation, when you are doing that, your breathing also gets regulated. Instead of fast breathing, your breathing comes to a more lower level, more balanced level. Breathing has got a tremendous impact. Whenever you are excited, you will breathe fast, because that goes with your agitated state. So if you have to reduce your agitated state, what do? You start breathing slower. When you start breathing slower, automatically you will see your stress levels coming down. You try this. I'm asking you, do this experiment on yourself. Whenever you are whenever you're in anger, whenever you're in anxiety, whenever you are uh, under the influence of a destructive emotion, something which has disturbed your equilibrium, drop everything. Just close your eyes and start breathing slowly. Do it deliberately, and you see the influence on you. That is what pranayama is all about. That is what we do in meditation. That is how it leads to a quietening influence. You see, working backwards, as they say. So when you do that, the amygdala calms down. your perception of threat, your perception of fear, it gets diluted. You become more normal. You become more balanced. You become more in touch with yourself. That is what mindfulness interventions are all about. You see? Do I make some sense here?
Yes, sir. Yes, sir.
Yeah. Also, one great source of stress has been which we started this discussion with, that we have everything and yet we see someone else doing better than us, earning more money than us. We feel that he's in a much better position, happier than us. And this especially happens when we keep checking Facebook accounts and we see what a wonderful life people have and we feel miserable. What is the issue there? You see, dear friends, there are many of us who live their life not because or not by what matters to them, but what matters to others. Understand what I'm talking about? We live our life by what matters to others, which means that when I do something, I do it. The first thought is, what will others think? Will the others be impressed? Will it make me appear good in other people's eyes? Instead of thinking what me matters to me. So the value system there is distorted. We don't pay attention to the signals that come from within us. Our emotional system, the structure in the brain which controls our emotional access and emotions, we call that the limbic system. That was given to us so that we may understand the signals that are coming from within us. Deep inside, your instincts are the emotions that you are feeling. Those are the signals that are being sent inside. And if you keep ignoring them, you are bound to end up into a stressful situation. So whenever we make a choice which is against our value system, which is against the feeling that we have inside, it leads to a stressful situation. Because there isn't any congruence from inside and outside. And that is where we create complications around our life. Does it make sense to you?
Yes, yes, sir.
So being self-aware means that being in touch with the emotions that we face. And once we get in touch with that, we develop what is known as emotional resilience. Emotional resilience is not just one step or one point, facet or a factor. Emotional resilience is a way of life. It's about being balanced in our approaches. It's about being, being able to retain the equilibrium mental state that we are in. Being able to retain that even in the face of adversity, even in the face of where negative emotions keep targeting us and attacking us. All right. So, any questions you have for me until this time, dear friends? I would love to take any questions. We have a couple of minutes.
I think still many more of them needs further motivation to speak up, sir. Apart
They
from
don't.
they
They
have, sir.
don't have the motivation to speak up. Have I been that bad?
No, 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 no.
No,
I think
sir.
maybe your session was too short for them to get further motivated. I think they want to hear long and then get motivated further.
I wish I mean I'm so sorry.
Yeah.
It has happened that way. I wish I had logged in through my laptop. I had prepared a
Yes.
presentation for you all,
Yes.
and I
Yes.
would love to handle your questions. I mean, if there are any questions from your side, it will give me an opportunity to elaborate more. Coming from I mean, logging in through a mobile, it doesn't really do justice, as a matter of fact.
Yes.
And especially WebEx has not been known to be a very interactive kind of platform, but that's okay. But if there are any questions from your side, I would love to handle that. I hope there has been some clarity which I've been able to share. And the power is playing havoc today. Any questions, Anil? Any questions, Gaurav? Any observations of yours? Any thoughts that you would like to share? Anything that you would want to contribute?
No, sir. Actually, that you have rightly said that means there are stressful things that happening. We need to control it, but sometimes we do a lot of things, but that is a few things are beyond our scope. We think that we should calm our mind down in such situations, but it's very difficult to control our mind. So sometimes we can able to handle it. Sometimes it becomes difficult to handle it. But in fact, whatever you have said so far, the method and like what happens actually, the you said everything about like how which part of brain controls them. So I think like probably most of them will are clear with like what we can be done to handle those things.
Yes,
I
sir.
think it will be helpful for many of us.
Thank you, Anil, for your kind words. Just one observation. You just mentioned that it is very difficult to control the mind. I agree. And why only mind? It is difficult to control everything and everyone.
Yes, sir.
Do you have kids, Anil? I mean, are you
Uh,
married? If I can ask you a personal question.
yes, sir. Yes, sir.
Do you have any kids around, or your
Yes,
nephews, or your nieces, or youngsters,
yes.
1 year, 2 year old? Try controlling them. Try controlling them. Can you? You cannot.
No, sir.
I've been married for 20 years. I've been trying to control my wife for 20 years. Hell, I have not been able to. And she controls me perfectly. Round her finger, she has me. Same is said about the mind. But the moment you stop trying to control it and start working towards regulating it, the entire dynamics change. The entire dynamics change. You don't need to control it. You just need to regulate it. That is number one. Number two, our problem is that our decisions are made not by what we feel, not by what we believe, but by what others believe. Till the time this paradigm is not changed, we will continue to exist under stressful situation.
Yes, sir. Absolutely.
The
Yes, sir.
largest source of stress in your life is the source where you know that you feel your thinking is in another direction, and you have to compromise, you have to surrender out of compulsion. Your values point in other direction and your actions point in totally other directions. You feel something else inside you. You don't pay regard to the emotion that you feel inside. When you disregard those signals, that is where you feel stressed. And that is why emotional intelligence has got a much larger role to play in handling stress. I'd like to share something with you all, and to all of you who are listening. The company which I represent, Synergy HR, we have an initiative at our place. We call it Siddhamana. So Siddhamana is a mental health and emotional wellness initiative. It's a not-for-profit initiative, which means that we charge a very nominal price for that. If any one of you is interested in conducting this program, it consists of 3 sessions, each of 1.5 hours to 1 hour 15, 75 minutes to 90 minutes duration. We talk about handling destructive emotions. We talk about hope. We talk about optimism. We talk about resilience. We talk about stress management in 3 sessions. 3 sessions consecutively. So 1 session each day. And after each day, we have a mindfulness intervention at the end of the session. It's a wonderful initiative. If anybody of you would like to, get it conducted at your place, we can do it virtually. We can do it online. And if things permit, we can do it offline as well. But if you are there, we would love to do it. And it will also give us a chance to, you know, go deeper, explore more, because it's a very pertinent topic, and you'll see that impacting your life, because that is the area that we work in. Would be too happy to be of service. Any other questions from your side, dear friends? I hope it has been some insights have been there, and you have been able to derive something of value from the session. Any questions from your side? Now would be a good time. Any thoughts that you would like to share?
Yes, the participants, anything like you want to ask?
That's fine.
Yes, sir.
That's fine, sir. I think everyone is.
Yep.
Yeah.
Gaurav, you were saying something?
No, just I was also saying this thing that it was fine, sir. It was nice session, sir.
Thank you. Thank you so very much. And
Thank you, sir, for a very nice session, sir.
thank you.
We really
I
enjoyed
thank
the
you.
session. It was a very interactive session.
Thank you.
In fact, I think it's the fifth day of our sessions. So it was a little bit of relaxation for us. Thank you so much for joining with us, sir.
Thank you. My pleasure.
Thank
Stay connected. Anil, it was a pleasure, and thank you so much for moderating and coordinating with the session. Thank you also for your inputs, Anil, Gaurav, and Vijay Lakshmi, of course. Thank you so very much.
Thank you,
Thank
sir. Thank you, sir.
Thank you. So I'm logging off now. Yeah.
Yes, sir. Yes, sir.
Okay. Thank you.
All the participants be with this link because we are going to we'll have a test at 3. So we'll tell you the nature and all. So be available at this link.
Hello.
Yes,
Hello.
sir.
Yes, sir.
Yes.
So, madam
Madam, Suma madam has joined, sir.
joined. And
Yes, sir.
Dean sir?
Dean, sir, not yet, sir, I think. Yes, sir. Sir has joined, sir.
Oh, you start it. Okay, and complete. I am doing another work.
Okay, okay.
And then I will share the question paper. Okay, when it will be over, you just ping me.
Okay, okay, sir.
Validity
Okay.
session when over, then you just ping me because I have to share the question paper. So all the candidates' emails ID are there, na? We used to email that
Yes, sir. Yes, sir.
in.
Email,
Okay, so
email
I will
IDs are
share
there,
the
sir.
question paper on that email. Okay.
Okay, okay, okay,
1
okay.
hour after this.
Okay, okay, sir. Okay. Good evening, sir. Good evening, madam. With your permission, can we start the valedictory ceremony?
Yes, yes. Dean sir has joined?
Yes, ma'am.
Okay, let's start.
Good evening to our chief guest, Dr. Rajesh Bhushan, sir, Dean Academics, NIT Manipur. Head of the department, Dr. Suma Adhikari, madam, and all the participants of the FDP. I welcome you all to the valedictory ceremony of the FDP program on recent trends of control systems in power electronic converters, sponsored by AICTE Training and Learning Academy and organized by NIT Manipur. Around 100 participants have enrolled for the program, and we had a 5-day long interactive session with our eminent experts on various topics. The sessions were highly appreciated, and this was known through the feedback taken from the participants. After a 5-day long intensive and enlightening sessions, we are finally going to bid farewell to an informative and interesting journey. I would like to request Dr. Suma Adhikari ma'am, HOD Electrical Department, to share few thoughts about the program.
Okay. Good afternoon. Respected Director, NIT Manipur, Professor Dr. Gautam Sutra, Dean Academic,
electrical engineer.
Singh, Professor IIT Delhi, Dr. Sukumar Mishra, Professor IIT Delhi, Dr. Rajesh Kumar, Professor MNIT Jaipur, Dr. Devasis Chatterjee, Professor Jadavpur University, Dr. Subrabata Banerjee, Professor NIT Durgapur, Dr. Tapas Kumar Shaha, Professor NIT Durgapur, Dr. Arnab Ghosh, Assistant Professor NIT Rourkela, Dr. Sailendra Kumar, Assistant Professor Maulana Azad, NIT Bhopal, Dr. Shukanta Haldar, Assistant Professor, SVNIT Surat, Dr. Santu Kumar Giri, Principal Scientist, CMERI Durgapur, my colleagues and participants of this workshop. And thanks to the efforts of our coordinator, Dr. Mrinal Kanti Sarkar, and faculties. This FDP program has become a grand success. And also, I would like to thank all the participants. And I believe that this workshop was informative and worthwhile. And thanks to all the distinguished expert speakers. And lastly, and most importantly, I would like to thank our respected director, sir, for all the support and motivations. Thank you.
Now, I would like to request our chief guest, Professor Rajesh Bhushan, sir, to conclude the event with his valedictory speech.
HOD Electrical, Dr. Samadhikari,
Dr. Menal, the Faculty of Department of Electrical Engineering. For the participants, this 1 week FDP program, recent trend of control system in power electronics water, conducted from 3rd of January to 7th of January. So this is under ATAL program of AICTE, and coordinator Dr. Manal has very well planned all the sessions, which can be seen from the by topic covered during the presentations. So there were 3 sessions each day, and program started from 3rd of January and completed on today. So the theme of the program is very much as per the need of present time, and I am sure that all the participants have been benefited from the rich knowledge which were shared by the different experts during the course of their delivery. Along with the technical sessions, there was one more session on stress management through emotional reliance. So these sessions are also very important, as you are aware that everyone is preoccupied with a number of activities, and in the current environment of lot of pull and push, stress management is also necessary. So this program has imparted you the knowledge in the area of power electronics, and I am sure that knowledge gained by you will be further strengthened over the period of time when you will read the various lectures delivered by the expert in detail. So once again, I would like to thank the Director NIT Manipur for his wholehearted support, encouragement, Department of Electrical Engineering for taking such a wonderful step, HOD Dr. Shoma and Dr. Miran Khan Sarkar, coordinator of the program. Thank you all. Thank you very much.
Thank you, sir and madam, for joining us for the validity ceremony. Thank you, sir. Thank you, madam. Now, for the participants, you will receive the question paper at your respective email, and it will be for 1 hour. So you need to answer within 1 hour and submit it. So you will receive the Google form with questions in it.
Within 5 minutes, I am sending. Okay.
Okay. So in another 5 minutes, you will get it.
Thank you for the participation, and please give the exam. Otherwise, your certificate will not be issued. I have shared the link.
Oh, okay, sir.
Please check it in your email.
Okay, sir.
हेलो, बोलो। हाँ, कहाँ पे सर? ये सर आप ही लोग कर रहे हैं, फिर भी इतना गलती हो रहा है सर, हम क्या करें? बताओ तो सर, सब्जेक्ट नेम क्या है? अरे ईमेल में कोई काम नहीं हो रहा है ना सर, समझा करो। E741 रुकिए, PhD। ये तो हम लोग भड़ा लग रहा है उस दिन। क्या क्या नाम है स्टूडेंट का बताओ सर? मुकेश कुमार यादव, थोंगजम, राजीव शर्मा, लोइथोंबम। तो है तो इधर दिख रहा है, लाइरोखपम हेल ओ ना। हम्म। आप स्टूडेंट का नाम क्या क्या बताया? राजीव शर्मा बोल के एक है, और एक विद्याराज। हाँ, तो विद्याराज सिंह तो किस में नहीं है? हाँ। फाइनाइट एलिमेंट मेथड फॉर स्टैटिक एंड डायनामिक प्रॉब्लम्स, C741। ये तो है सर, इधर तो दिखा रहा है। कोर्स अलॉटमेंट दिखा तो रहा है सर। ओए, चेक करो चेक करो चेक करो। रुको सर, रुको रुको। PhD सिविल इंजीनियरिंग। टीचर स्टूडेंट एनरोलमेंट जाओ, इधर दिखा रहा है PhD सिविल। हाँ, ये फर्स्ट ईयर का ना? फर्स्ट ईयर का। सब्जेक्ट का नाम है 701, फाइनाइट एलिमेंट मेथड फॉर स्टैटिक एंड डायनामिक प्रॉब्लम्स। कोड है CE741। सच्चिदानंद, सच्चिदानंद आमा स्टूडेंट होना चाहिए, 2 स्टूडेंट होना चाहिए। स्टूडेंट का नाम है वैद्यराज राजीव शर्मा। क्या गलत है क्या? हाँ? चेक करो भाई, ये क्या था मैम? यूपीसी मीटिंग इलेक्ट्रिकल, यूपीसी है ये। काटू, साइन कर दीजिएगा। थर्ड जनवरी है तो सर थोड़ा होल्ड ऑन। हाँ, स्टूडेंट का एक का तो है 20401002। साइन तो इधर दिखा रहा है सर। आपका 2 बैच है ना, आप देखिए, आप 21 में बैच सिलेक्ट सही से कीजिए। अगर कुछ गड़बड़ है तो इधर आके आइए, हम दिखा देंगे आपको, ठीक है? 100% दिखाएगा सर, ऐसे कैसे हमारा सॉफ्टवेयर? तो आप बैच अलग चेंज कीजिए। जब मार्क्स एंट्री मारता है ना सर, जब मार्क्स एंट्री मारता है ना सर, उसमें सेशन सिलेक्ट करता पड़ता है ना, तो उसमें जाके देखिए वो अलग बैच का स्टूडेंट क्या रे, इसीलिए क्या हुआ प्रॉब्लम, को सर उन लोग करेक्शन कर रहे हैं। एवरेज बाद में अगर पता चला है नहीं, कोई क्वेश्चन नहीं करो, एक कैलकुलेटर दो ना, क्या हुआ सर, का प्रॉब्लम सॉल्व हुआ कि नहीं लगी सर, थोड़ा रुकिए, चल रहा है, ठीक है, थोड़ा होल्ड कीजिए। 45 54 55 plus 54 0 divided by 3 83 हो रहा है। एक सौ दस 55 110 165 हो रहा है ना, 55 इसको किसको लिया है, इसको ये सारा इंटरनेट में अपलोड करेंगे,
एक ही अपलोड करेंगे।
ये वाला कौन सा हुआ, अलग से बनाएंगे, ये जो प्रोग्राम क्या हो गया रे इतना, ये थोड़ा साइन कर दीजिएगा जो काट दिया।
Sir, can we leave the session after submission?
Yes, you can leave the session. Okay, thank you. And you please give the overall feedback. We will share with you. Okay.
Okay, sir. Sure.
After some time, we will share the feedback form for overall feedback, and as well as we will send the your email ID, name, your parent institute details. Okay, date of birth, everything we will send. You please correct it if something means if required. Okay, otherwise if there is any mistake, na, then your certificate also it will reflect. So please carefully check and correct and send us. Okay, we will share after some time. Means today by 5 or 5:30. Okay, you please check your name, your good name, your surname, and your parent institute address. Okay, and your date of birth, all other like email ID and necessary things. You please check and carefully and send it us. Okay, okay, it is correct for my side like that. Okay, then only will proceed. Otherwise, your certificate will come in with wrong name or wrong institute name. So it could be correction after issuing the certificate. That correction becomes difficult actually. But it is better to send correct thing to them so that they can give you correct certificate. Okay.
Yes, sir. That will be posted. Certificate will be posted to us, or it will be sent in mail.
No, you can download from this your ATAL
E-certificate.
profile.
So you will send e-certificate.
And ATAL will issue your e-certificate. Okay, and from institute side we will not send anything, right? Because
Yes,
we are
because
not
earlier,
we don't have
earlier
any
when
authority to issue any certificate. Okay, ATAL only can give you. Okay.
Yes, sir. Yes, sir. Why I am asking? Because last time when I attended one ATAL FDP, they have sent through post. So that's why I am asking.
Okay, okay. If now I think that was on
Please.
offline mode, I think, right? You have
Sir, online mode only, sir. Online mode only, but they have sent through
okay.
post.
So let's see.
To
Okay, if is there any provision, so definitely we will send. Then you have to give your correct postal address.
yes, sir.
Okay.
Yes.
During
Okay,
the
sir. Anything,
your
please
Excel
inform
file.
through mail, sir.
100% we will send you mail. Otherwise, your certificate will be the useless, na. So
Yes, sir. Yes.
we will take care of all these things. And lastly, I can say you thank you to join and be with us for last 5 days. Okay. So in future, we will try again to collaborate with you with the various form. Okay. If you, we may conduct other short-term course as well as we may if we conduct any short-term means lecture, special lecture session and all, then we can send you the request. Okay, to for the join of all those for the participation. Okay, thank you.
Yes, sir. Thank you.
Thank
Okay.
you. May now.
Hello, sir. Thank you very much.
Yes.
Sir.
Yes.
Sir, the Nirala has not received that, sir, mail, that question paper.
Actually, many of us have not got the question on mail, sir. So can you please share that on the group, sir?
Okay, I am sending in WhatsApp group.
Yes, sir. Yes, sir.
Okay, this is the problem actually. That's why I am telling you. Please check your email ID and all. Okay.
Yes, sir. Actually, I am checking, sir. It's not there right now, sir. So can you please share this on the group, sir,
Okay.
please?
Control-C. Group. Where is the group? Send it. Please check it.
Yes, sir. Yes, sir. We got now, sir, on the group, sir.
Yes, sir. In the group it is there.
Actually, registered participant was 102. Please tell them, okay? So that
Okay, sir.
Okay.
target is you want to issue certificate as more and number would be more.
Yeah. Yes, sir. Okay.
Sir, actually we added in group now, sir. Many of them thinking that they will get in WhatsApp. So just now I conveyed, sir. So they are taking.
Okay, no issue. Okay, tell them.
Okay. Okay. Sir.